Hello, everyone, and a very good morning. Distinguished delegates, presenters, and participants from SAARC member states and other regions around the globe. It gives me a great pleasure to extend you all a very warm welcome on behalf of SAARC Energy Center. I'm very thankful to all of you for joining us in the SAARC webinar on designing energy efficient buildings in SAARC region. I'm Dr. Tanveer Ahmed, and I'm working at SAARC Energy Center as Program Leader Technology Transfer. I shall be moderating today's webinar. Ladies and gentlemen, globally, the buildings and allied construction sector account for 36% of the final energy consumption. With increased urbanization in the SAARC member states, it is envisioned that the number of buildings will increase in future, which will result in increased demand of electricity. Most of the member states in SAARC region are energy deficient and thus have very little margin between their existing supply and demand. With the increased demand of electricity, more investment in new generation sources would be required in future. One of the effective ways of reducing electricity demand is through constructing energy efficient buildings and installing energy efficient appliances in them. The investment in an energy efficient building is 2 to 3 times less than the cost of investment in the supply side of the energy system. In buildings, space heating, space cooling, and lighting, which together accounts for most of building energy use, depend not only on the energy efficiency of temperature control and lighting system, but also on the efficiency of the buildings in which they operate. The building's design, constructions, and material have a significant effect on the energy consumed. Windows also significantly contribute in energy efficient of the buildings. Heat gain and heat loss through windows are responsible for 25 to 30% of residential heating and cooling energy use. The SAARC region has very diverse types of climates in different areas. The design and selection of an appropriate option before constructing a building at every step is very important and need of the day. I am extremely grateful to our elite panel of presenters from China, India, and Pakistan for joining us today. Dear participants, you will have the opportunity to ask questions to presenter by typing your questions or clicking to the raised hand option into the attendees pan of the main window of GoToWebinar software. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of each presentation. Additionally, you will also have a chance to share your views in the knowledge sharing session of the webinar. Well, ladies and gentlemen, let's move to the technical session and start with formal presentation. Our first presenter is Mr. Shubhashish De, who will be talking about green building in a post-COVID-19 India. Mr. De is a climate change and energy efficiency professional with 17 years of experience and provides strategic planning, leadership, and guidance to SHAKTI's energy efficiency program. Prior to joining SHAKTI Foundation in September 2016, Shivashish was working with Ernst and Young as Manager Climate Change and Sustainability Services, and has worked with Sodexo, IGA Energy, and McKinnon and Clark in the past. Shivashish is postgraduate in Energy Management from Indian Institute of Social Welfare and Business Management and BE in Electronics Engineering from RCOEM, Nagpur University. Over to you, Mr. De.
Good morning, everyone. Greetings from Shakti Sustainable Energy Foundation, India. First of all, I would like to thank SAARC Energy Center and Dr. Tanveer Ahmed for inviting me for this webinar. Before starting this webinar, I would like to understand that whether my voice is audible to all.
Yes, sir, it is audible.
Thank you. And my screen is also visible to the participants, I believe.
Yes, sir.
Great. Uh, thank you again for inviting me for this webinar. And this is a critical time of this century. I would say that when we are facing unprecedented challenges posted by a virus which was unknown to the mankind prior to its outbreak uh, in this region a couple of months back. Now, this outbreak has posted certain challenges and also opened up certain opportunity for us. Uh, my presentation, since because of this outbreak, there has been certain economic impact, there has been certain environmental impact, and these impacts will definitely have uh, a bearing on how we humankind will be living our life in next couple of years. It might
Yes,
not
sir.
have a large scale impact in centuries to come, but definitely in the decades to come. With this background, I would like to start my presentation named Green Building in the Post-COVID-19 India. The presentation is divided into five part. You might not be aware of the organization I'm working, that is SHAKTI Sustainable Energy Foundation. So I'll maybe spend 5 minutes on that and then talk about why we are talking about the building sector, the impact of COVID-19 on this sector, and then what are the remedial measures we can think of. SHAKTI Sustainable Energy Foundation was set up in 2009, and this is a unique organization per se, where we are a re-granting organization. Now, you might be aware of foundations who provide funds for developmental activity. You might be aware of civil society organizations who receive those funds and utilize them for different developmental activity, whether it is in the energy sector or health or education, livelihood generation sector. But we are unique in a way that we are neither a funder nor a executor. So we are someone who is in between. So what we do, we accumulate funds from different funders, from we receive those funds from different global philanthropies. Many of them are based out of US, Europe, and India. Accumulate that fund, create uh, and create a larger fund, because you can understand that all if any of these organizations were deputing their own fund for certain activity, those activities might have been smaller in size. But when we accumulate funds from different organizations, create a larger basket of funding, then it becomes so we are in a better position to address larger issues. We are in a better position to deep dive into issues, remain committed to a specific issue for a longer duration of time. As an organization, our vision is to develop a clean and secure energy future for our country, that is India. And we work on 5 thematic areas. It includes energy efficiency, which is subdivided under buildings, industry, and cooling. Then we have transport, which looks at sustainable transport and then electric mobility. Then we have power sector program, which looks at utilities, renewable energy development, and distributed renewable energy generation. Then we have 2 overarching programs: the climate policy, which looks after low carbon developmental strategy, and then on air quality. The final program which we have is clean energy finance, which is self-explanatory. Now, as I was mentioning, that we are unique in a way that we are the only re-granter which is working in the climate domain currently in the country, and I'm not aware of any other re-granter that may be my lack of knowledge in any of the other SAARC region. So when we were discussing with Dr. Ahmed, so he also shared that the model in which we work can be useful for developing similar organizations within other SAARC sister countries. So what we do is we work as a system integrator. So we bring in knowledge as well as we bring in funding from different sources. Then we run cross-cutting campaigns. We develop partnership with civil society organization within the country, foreign civil society organizations, as well as with other funding agencies, bilateral, multilateral agencies, and also with the government departments and ministries. Then we run strategy, and then we run strategic program management. So as I was mentioning, that we have 5 programs, and if, each program has developed their own strategy, which looks at a goal of restricting the temperature, global temperature rise within 1.5 degree from the pre-industrial era. And for achieving that target, we have certain strategic objectives and then the roadmap. So and then we utilize our funds for supporting different through different initiatives, supporting Government of India and other state government departments to achieve those targets. As I was mentioning, that we manage the philanthropic resources for other foundations, and one strong actions which we had been successful in promoting is early policy actions, early stage policy actions. I've already shared the different verticals in which we work. A few of the policy outcomes from which are really useful for the building discussions. So in SHAKTI was instrumental in supporting the Government of India for developing its India Cooling Action Plan, which is a 20 years foresighted document where we had strategized and developed pathways that what India should do in the next 20 years to provide sustainable cooling. Sustainable cooling means climate-friendly cooling for all its citizens. As you might have also seen a recent report which says that by 2100, India's temperature in a business as usual scenario would increase to almost like 4 degrees centigrade. So, and anyways, India and our neighboring countries like Pakistan and Bangladesh, Sri Lanka are tropical countries. Nepal and Bhutan might not be, might fall under temperate and cold region, but these 4 countries within the SAARC region, including obviously again Maldives, are hot and humid climate or dry and hot weather we frequent. So cooling is very important. So we developed this strategy and we were instrumental in supporting Government of India to develop that document for the ministry. And it was officially published by Government of India last year. Similarly, we had been supporting the Government of India's initiative to includes the existing buildings, the existing commercial buildings as one of the sectors which becomes designated consumer. So we have a scheme within the country which is a cap and trade scheme under which every large energy consumers are given certain targets within which they have to limit their energy consumption. If you are not able to remain within the target, then you have to either pay penalties or buy certain certificates. And if you overachieve, like you are way beyond inside the target, then for that component you will get certain credits which you can sell to someone who has not achieved the target. So initially only the industry sectors and the power generation sectors were included in this scheme. In 2018, with support from SHAKTI Sustainable Energy Foundation, the Indian government also included hotels as one of the subsector from the building sector. So progressively now we are in the process of including other subsector within the building sectors like hospitals and airports as we move ahead with this scheme. Similarly, many of you might have heard of this India's LED program, which has been successful in supplying around 360 million LED bulbs to poor household within the country and around 200 million households to normal commercial channels. And nowadays, whenever you visit any of India's household, you will hardly see an incandescent bulb. You will see always a LED bulb, not even a CFL bulb. That program was initially designed by with the support of SHAKTI Sustainable Energy Foundation in one of the union territories in southern part of our country, Pondicherry. That was done in 2012-13, and then the project was successful in Pondicherry and then was picked up by Government of India and replicated across the country. So these are certain policy actions which we had supported in building sector. There are many more, but these were three key policy actions which have taken over last 10 years, which I within the building sector, which I would like to share with you. Now, coming back to the main part of the building, our presentation, as Dr. Tanveer Ahmed has already said that building sector, Dr. Tanveer Ahmed has already said that globally building sector consumes around 36% of the total energy consumption. Within India, building sector consumes around 33%, 24% from domestic, 9% from commercial, 33% of the electricity consumption. If I'm talking about the primary energy consumption, it will be around 16 to 17% of the primary energy consumption. Most of our primary energy consumption goes for power generation, followed by industry and transport. And within power generation, you can see that around 33% of it is consumed by the domestic sector. Currently, even within power generation, the bulk goes into industry, but progressively as we move, all indication shows that we are going to, the building sector is going to surpass the consumption by industry sector, at least for the electricity consumption is for the by 2030. So we are going to surpass the industrial consumption, which is also the global trend in most of the developed economies. Within the domestic sector, you can see that currently domestic and commercial sector, you can see the breakup for commercial sector is currently lighting, followed by air conditioning. In residential sector, it is fans, followed by lighting, and then refrigeration and air conditioning. Refrigeration means the household refrigerator. But going forward, we also see a trend where the consumption by the air conditioning sector is going to increase exponentially. The growth has been pretty steep for the country as far as the sales of new air conditioners are concerned. So by 2030, again, we have the understanding that the principal load, electrical load generated by the building sector will be from the air conditioning. So as we all know that most of the countries within SAARC region are energy deficient in terms of even for India, which currently we have like for last couple of years, we are energy surplus in terms of the electricity which is produced and consumed. But that comes with a caveat that we are not really seeing the full potential coming from the residential sector. Though by last year we have reached almost 100% electricity connectivity to every household, but that does not mean that all these households are really consuming the kind of electricity which they would require to consume to reach a level of human developmental index which is required for a safe and healthy livelihood. Which is not the case. So, for example, most of these rural households does not have any kind of cooling or thermal comfort equipment. So they do not use any kind of fans. So forget about air conditioner. Even in certain urban slums, the housing conditions are really bad, really poor as of now. Though the government of India and other private entities are working in that regard, but it's still pretty bad, the situation. So with that, we can understand that there is a definite need for looking at the building sector, understanding from both two perspectives. One is the supply of electricity, other is the peak demand, which even International Energy Agency in its report which came up on report on cooling, which came in 2018, also highlighted the fact that the peak demand for from air conditioning only by 2050 for India would be like 800 gigawatt. So to give you a perspective, so total energy installed electricity capacity within the country right now is less than 400 gigawatt. So by 2050, only the peak demand from air conditioning can reach 800 gigawatt. Now, coming back to the other aspect, like we understand the building is very important aspect, and we need to understand the energy consumption from the building sector and how to reduce it. But while working on that, there has been a unprecedented impact which is generated because of the COVID-19. And what we have seen that, and even the government of India has realized that most of these victims of COVID-19 are urban. So COVID-19 has been an urban-centric viral infection. Though we are now seeing some rural penetration of COVID-19, but those are also in areas within the rural segment where the people, the migrant laborers from the migrant workers from the urban centers had moved to the rural centers, and they have carried the virus along with them. Again, we have seen that unavailability of safe, healthy, affordable housing in cities is one of the principal reason for this reverse migration. So the rural India would not have been impacted if these migrant workers had some healthy living conditions within the cities during this viral pandemic. The spread of COVID-19 infection of India indicates that during the pandemic, where self-isolation was very important, the people who are affluent, coming from the stronger economic class, they could isolate themselves better. But people who are living in either unauthorized colonies or in slums, you can see two areas from one is from Delhi, which is Jahangirpuri, the other is from Dharavi in Mumbai. These are the two cities, Delhi and Mumbai, which are the worst infected or affected by COVID-19, followed by Chennai. And these are two urban clusters within these two cities, which are the worst one of the worst infected. So one is Jahangirpuri, where you can see a lot of unauthorized construction. The other is an urban slum of Dharavi, which is one of the largest slum within Asia, where obviously you cannot have self-isolation. So it doesn't really work. The houses are small, the ventilations are poor. So you cannot really remain within those houses for a longer duration and keep yourself self-isolated. So housing and how those houses are constructed, the ventilation, thermal comfort becomes more important. Understanding this importance, the government of India has come up with, you might be aware that Indian government has come up with a incentive package, a economic stimulus package, which is going to around 20,000 billion Indian rupees. And that has a very high focus on developing housing for the economically poor section of the society. So there are different schemes you can see. So schemes on PMAY is Pradhan Mantri Awas Yojana, which is a scheme for affordable housing within the country. So around 70,000 crores. So it's we convert into billion, it will be around 700 billion Indian rupees has been sanctioned for the mid-income group, to support the mid-income group to buy new houses. Those houses would be developed in a way that they are well ventilated, have better thermal comfort in place. Similarly, some real estate sectors have been boosted with a liquidity of 300 billion to support this construction of these affordable houses. At the same time, they also have opened up different mechanism for those affordable houses. So earlier on, those affordable houses could only be bought by either the urban middle class, middle income group or low income group. But now, after understanding the impact of COVID, where the migrant workers and students and professionals had to move back to their hometown because they didn't have proper housing in the city, the housing which where people can live a decent life. After understanding that, the government of India have also announced now a scheme under which those affordable houses will be developed where they can be rented out. So somebody does not need to buy those affordable houses. The government agencies will rent those affordable houses to migrant workers and students. So these all these stimulus packages, though they are announced, but they do not come with some explicit mention of these houses has to be green or energy efficient. So this gives us, agencies like us, SHAKTI and other bilateral, multilateral, and the other civil society organizations who are working in this domain, an excellent opportunity to work with different arms of the government of India and make sure that these houses, when they are constructed, and since the money is available on the table, so the construction will be faster. So when those houses are constructed, they are constructed in a way that they are both energy efficient and follow green building practice. For example, to give you an example, we are in a pretty serious discussion with one of the state governments of the country, because those houses will be, after all, constructed by the state government agencies, state government of the country, where they are in a process of developing 400,000 new houses for urban poor, and those houses will be provided to the urban poor either free of cost or with a minimal cost to these urban poor. And they have reached out to us to support them to so that those houses can be made following the principle of thermal comfort and green building. So as I was mentioning, that there are key focus area for us. So we are focusing on both embodied energy, thermal comfort, and the operational energy. And in terms of COVID-19, you can understand that there are indirect impact of thermal comfort, be it the productivity of the person who is living within, the health and well-being of the occupant, and in critical future calamities, because this pandemic is maybe the first of many of these similar kind of pandemics which we would see, and many of the researchers are also linking these pandemics to climate change. So thermal comfort and good housing becomes very integral for people to safeguard their health and well-being during this kind of pandemics. There are a number of enablers which are available and developed by Government of India and different agencies. So that includes the National Building Code, which has a specific chapter on sustainable buildings. Then we have Energy Conservation Building Code for commercial building. We have Econivas Samhita, which is nothing but an energy conservation building code for residential consumers, residential sector. Then we have Indian Cooling Action Plan, and then we have green building codes, Indian developed green building codes. One is this Indian Green Building Code, the other is Griha. These are the two pretty popular green building codes within the country, and there are other green building codes which are also followed within the country, which are more international in nature. So the way forward for us is that we need to adopt the principle of lean, mean, and green. And what lean and mean and green means is that we need to understand first whether the growth has to be need-based or want-based. So when we come up with a new construction, whether that construction is required or not, we need to assess that first. Then we need to also take a step back and think that whether our growth model should be GDP, percentage of GDP growth year on year, or it should be plugged onto the Human Developmental Index, because countries like most of the countries in the SAARC region, be it India, Pakistan, and uh, Bangladesh, Sri Lanka, had high GDP growth at different uh, era, but that we need to self-introspect and understand whether that GDP growth has really translated into Human Developmental Index for the bottom of the pyramid for all these countries. The answer is often no. So we need to understand which kind of growth model we have to uh, take into consideration. Whether the growth model should be urban centric or holistic. The COVID-19 has already shown us that the urban centric growth model is not sustainable. Whenever there is this kind of calamity comes, the people have to go back to the villages, and when they go back to the rural areas, they carry along those infections along with them, and then when they reach those rural areas, they do not have sufficient uh, employment opportunities. So the growth which has been till now, and that has also created those urban infrastructure, houses, uh, uh, these heat islands within those urban centers, increased consumption of electricity in these urban sectors, had impact on energy security of the country, and then the ripple effect, so on and so forth. Never been holistic. So we also need to understand the development has to be holistic. We have to create smaller centers nearer to the rural India, so that people from, say, if you are able to understand the geography of India, people from West Bengal does not need to necessarily travel to Maharashtra or Delhi for their livelihood and cover some distance like 1,500 or 2,000 kilometers to reach places where they could get some livelihood and live in houses which are not really meant for human occupancy. So lean means you need to optimize the demand. Mean means you have to manage the resources efficiently, and green means you need to use low carbon and carbon neutral resources. The next section we will be discussing mostly these three specific components. So we had been following this demand management for a very long time. So if we see those old architectures of ours, be it the Taj Mahal or the Gol Gumbad or the buildings which were created during the colonial era, say they do not require a lot of air conditioning or cooling equipment per se. The construction was such that the passive cooling architectures were followed. Natural resources or locally available resources were utilized. Again, with COVID-19, we do understand that there are restrictions now of movement of movement of construction materials. So we need to also now understand that how you can build something which is locally appropriate, utilizing those local resources. Similarly, first we have seen a building which was old. Now we are seeing a building which is new, but has been utilizing those principles of old jharokas or the jalis or the fenestrations, which lets the sunlight come in, but not necessarily the heat to enter the building premises, and reduces the thermal load of the building to a great extent. Similarly, we have talked about cooling, but we can also talk about heating. So this is the Sakmol campus in Ladakh, which has actually utilized traditional building architecture, which is very Ladakhi in nature, as well as building materials, and they can sustain living within this building without any kind of artificial heating at a temperature of around -12 to -20 degrees centigrade. I have personally visited this center, and these photographs are taken by me. And I visited the center when the temperature was around -15 degrees centigrade in the night, but we did not require any artificial heating within this center. It does not really, and when we talk about architecture and urban design and talk about tradition and modern, often we come to loggerhead, but that is not the case to be. So as by the uh, as the renowned architect Laurie Becker has said, that every district has its own tradition, and by trial and error over thousands of years, people have learned how to use and to cope with all the and many factors which are involved in architecture. So it is foolish, therefore, to abandon the time-tested findings of centuries of science and technology, and then just take something which is uh, uh, urban in nature, the generic urban in nature. So you can see in your like presentation slide, I have shown six uh, pictures. Of that, there are on your right hand side, there are some buildings which we see everywhere, and then on the left hand side, we can see buildings which are very uh, uh, very topical to that region. And the fun part is that I have taken the building, the figure on the right hand side. For example, this is taken from a house in Assam near Guwahati. This is also a house in Guwahati. This is a house in Kerala. This is also, sorry, this is a house in Tamil Nadu. This is also a building in Tamil Nadu. This is a building in Jaipur. This is also a building in Jaipur. So if you can see the buildings on the right hand side, they all look similar. The buildings on the left hand side looks different. So again, when you love your city, so when you do not, if you lose out your uniqueness of the uniqueness which is diverse in nature. So most of the countries in South Asia have their own uniqueness in terms of their regional diversity. So if you lose out on those uniqueness, then at the end of the day, you also lose the love of the city. So earlier on days, when for our grandfathers and our forefathers, they had very difficulty to move from one place to other. So they did not really feel like leaving their houses, because those houses are very unique to them. They were built by their forefathers or by them themselves, and they were very unique to that region. But nowadays we move into one apartment, and after few years, we don't like that apartment anymore. Then we sell that apartment, move to another apartment, and maybe to a different city altogether. So that attachment which is there, which link a person to its neighborhood and make that neighborhood their own, we are losing out on those. On mean, we are aware of different different technologies which are available. I'm not going to spend a lot of time on them, because those are readily available in the internet. So there are technologies which are new, like solid state caloric technology, vapor compression technologies, evaporation technologies, vapor compression and dehumidifying technologies, evaporative cooling with dehumidifier, which can provide, say, cooling without consuming a lot of energy. So there are new technologies coming up. My presentation is available with the SAARC Energy, and they can share with all the listeners. So, and now on talking about technologies, that there are technologies like this radiant cooling technology, which is costly. So there are considerable amount of first cost, but provides high degree of thermal comfort, and at the same time there are ways and means which are affordable and provides thermal comfort, like cool roof. So one is an example from a place named Kutch in Gujarat, where they are using those costly technology. The other is a cool roof which is used in Hyderabad, in Andhra Pradesh, where they are using this affordable uh, means of providing thermal comfort. So based on your requirement, based on your ability to spend, you can pick up any of those technologies. In terms of green, we all know about the concept of net energy zero building. So we reduce the demand or electric demand or the energy demand of the building by doing the right design, and then also utilizing the right building material. Thereafter, we use efficient equipment to further reduce the requirement of energy, but there will be still certain requirement of energy, and that can be then uh, met by renewable energy resources which can be building integrated, renewable energy resources which can be off grid. So there are different mechanisms to progress a building from near energy zero to net energy zero. In terms of refrigerant, you might be also aware that the current refrigerant which we are using, which are mostly R32, R14, or in certain cases R22, they have very high global warming potential. So you might be also aware of this Kigali amendment to the Montreal Protocol, where almost all the countries have signed that protocol, and the protocol has been ratified after signature of after the ratification of a number of countries, mostly from Europe and Africa, that we have to progressively reduce uses of those high GWP gases, F gases, and there are natural refrigerant options which are there, like hydrocarbon, ammonia, carbon dioxide, isobutanes, which progressively will see more uses. There are artificial refrigerant also, like HFO, which are R1, 2, 3, 4 Y, that is HFO, which has also low GWP potential. So we need to now progress when we use refrigerant in air conditioners from those high GWP refrigerant to low GWP refrigerant. So that would be more on the greener component. With that, I would conclude my presentation. I know that I might have taken 5-6 minutes more from my stipulated time. And if you have any specific questions, I am here to answer those.
Thank you so much, Mr. Shivashish. I mean, that was a really nice presentation, and certainly the audience had different insights to these buildings. So I have some questions from the audience, and the first one is that does Shakti Foundation, do you guys work only in India? And if that is the case, then what if somebody wants to have the same like business model in other SAARC member states under the umbrella of Shakti Foundation? So do you provide any assistance or something like that?
So in terms of our geographical focus, so when the organization was constituted, the constitution was such that we are mandated to only work within the boundary of the country. But as I was mentioning, that we work closely with other civil society organization of similar nature, like the Energy Foundation in China. We are kind of a sister foundation to them. So we work closely with other foundations, like Energy Foundation in China is a similar nature foundation like us. So they are also a re-grantor, so with whom we have close links. Now, to the specific question of working with developing similar foundations within the SAARC country, so we will be very happy if any of similar organizations can be built in the SAARC country. So we are able to provide our technical assistance in terms of the knowledge which we have gathered working in India, like how this organization has to be constituted, how you need to reach out to different funders so that we can create that coffer which can be utilized, how you develop your strategies or the country strategies for different thematic areas under energy. So those kind of a hand-holding support we will be more than happy to provide if any of the SAARC partner organization is willing to take our support.
Okay, thank you for that. There's another question. What do you think? What are the challenges and opportunities for energy efficient retrofits for the existing buildings?
See, the only challenge, but I can see is the first cost. So beyond that, it's as far as India is concerned, most of the Indian commercial building owners, they understand the importance of using energy efficient equipment, and many of the large commercial premises, they have their own in-house energy managers. They do understand the importance. Earlier on, there were debate on split incentive, that the building owners do not consume energy, but is consumed by the tenants. That debate has also gone to the back stage, because the building owners do understand that if you do not provide reduce the operational cost, the tenants may move out to some other building which has a lower operational cost. So those have actually instigated people to uh, uh, invest in retrofits, but the only challenge is in most of the cases is the cost of those retrofits. Somehow we are not, in all the retrofits, we are not able to uh, manufacture those retrofits locally and bring the price down, and we have to rely on uh, most of the components needs to be imported. Say for the building automation system, most of the electronic items needs to be imported. They can be assembled within the country, but most of the components need to be imported, and then it increases the cost substantially. So those are the challenges which I see per se when we talk about retrofit. For example, for residential consumers also, the challenge has been the cost. Like Shakti had and other organizations also. So, like we have one program where we are working with a utility company within Delhi, that is BACS Yamuna, where we are now starting a AC replacement program. So what that program invariably say that you can replace your old inefficient AC and buy a 5-star. So we have a rating system. 5-star is the most efficient AC, which also uses a low GWP refrigerant, not R22 or R14, maybe R32 and below. And we are providing you that AC at a cost which is with the half of the maximum retail price. So there is a MRP, and the my cost uh, price which is offered for these consumers who would like to replace their old AC or non-working old ACs with this new efficient AC at a lower cost. So cost had been the important phenomena, and then we are trying different mechanism to address that. As I was mentioning, that now we are also in a process of promoting low energy affordable cooling devices, like you have used to have those desert coolers earlier on, but as with climate change, the hot and dry places within the country like Delhi has hot and humid summers. So in those time you cannot rely on the normal desert cooler. So you have now dehumidifier based desert coolers, which actually reduces the humidity within the room. And so those are not as expensive as air conditioners, but maybe marginally more expensive than the normal desert coolers. So those are ways and means we need to innovate to understand the need of the consumer, the pocket of the consumer, and come up with technology options that can be utilized as retrofit. I hope I could answer the question.
Yes, sure. Okay, one few more questions. What is the impact of affordability on this energy efficient buildings? And what do you think? Like, I will combine two questions. How much more financing is required as compared to a traditional building for an energy efficient or green building?
So it's a beautiful question, actually. Now, there are two kind of building I may broadly segregate. One is the affordable building. The other is the building which are for the high income group. So if I need to make a building green and at least introduce the basic concept of thermal comfort for an affordable building, and that I'm telling you with all humility and with a lot of research where we had deliberations with large developers, building developers, or real estate developers within the country, that the cost escalation for affordable buildings, and if you follow, say, for example, the affordable building guidelines by GRIHA or IGBC, Indian Green Building Council, the cost escalation is either 0 or 1%. If you
Okay.
include, with a caveat that if you include these design guidelines from the uh, inception of the project, for the high-end housing, where you when you make it green, you also include a lot of more uh, components which are uh, and components which are not only energy efficient but costlier in nature. So there the cost escalation can be from 5 to 10%, but not beyond 10%. So we have also seen buildings in Pune by a developer named Orange Country, who had made those his buildings net energy zero, almost net energy zero, and these are like mid to high income group housing, and their cost escalation was around 7 to 10%, not beyond that.
Okay, great.
Compared to any
Thank
of the
you.
construction in the same neighborhood.
Okay, that's really nice to know. So there is another question that we like, due to this climate change and global warming, the temperatures are almost rising every time. So what are the methods for sustainable cooling, and any funding opportunities like international funding opportunities that are available for efficient cooling?
So the biggest international funding opportunity is coming from two uh, areas. One is the philanthropies, the other is the MLF, the multilateral funds. So you might be aware that all these multilateral organizations like World Bank, European Union, and bilateral organizations also, many of them like USAID, uh, British High Commission, now the DFID is no more, so the UK FCO and Swiss Agency for Development and Cooperation. So they have, these are few funding organizations, bilateral, multilateral organizations who have dedicated funds available, country-specific dedicated funds available for these cooling related interventions. They are definitely there in India. They must be also available in Pakistan, Bangladesh, and Sri Lanka, even in Nepal. As far as the philanthropic is concerned, so the largest philanthropy, the most of the climate philanthropies came together in 2016 after the Kigali Amendment to the Montreal Protocol and developed a network of philanthropies known as the Kigali Cooling Efficiency Program. So that KSEP program. So the first tranche of the KSEP program, they have actually deployed 50 million USD as catalytic investment to support energy efficiency and to a certain extent reduction of uses of those high GWP F gases in cooling. So during the first tranche, within the SAARC country, Bangladesh being one of the country which got a lot of benefit out of that. There is a company named Walton in Bangladesh who are the largest manufacturer of household refrigerator, and they also manufacture ACs. So their units had been also converted so that they can use R290 as refrigerant in their refrigerator units. So similarly, KSA program has worked in Bangladesh. They did not work in other SAARC countries like India and Pakistan because they, during the first phase of KSEP, where these $50 million were deployed, and they were deployed by civil society organizations and also through multilateral, bilateral organizations like World Bank, UNEP, UNDP. So they also got money from KSEP, and they were deployed in countries which were in Article 5, Group 1 countries. So among the developing countries, there are two groups. One is who has a more ambitious target. Bangladesh falls into that. There are countries which do not have ambitious target, so much ambitious target. India and Pakistan fall into that group. So during the first phase, India and Pakistan was not included. But during the second phase, which is will be starting from 2021, countries like India and Pakistan will be also be able to avail that benefit. So you can go to KSEP's website, you write KSEP and Kigali in Google, you will find their website.
Okay,
and
sir,
you can reach out to them.
because we are limited on time, so I have these three questions. If you could just take like a few seconds to answer these questions.
Sure.
The first one is, are you aware of any studies to use the traditional passive cooling techniques that can be adopted in new buildings?
There are multiple studies which are available. So there are studies done by organizations like SEP. I'm talking about India. Organizations like SEPT University, studies done by Indian Green Building Councils, KRIHA, TERI. I will be able to share those studies if you with Dr. Ahmed, and then he might be able to share them with the person who has asked the question.
Okay, thank you, sir. Then the next question, what are some recommendations in the Indian Cooling Action Plan? Some major recommendations.
Sure. So the major recommendations under the cooling action plan is that we have to provide. So the first recommendation or the first goal, the recommendations come from the goal. So the first recommendation goal is the biggest goal is that we need to provide thermal comfort to all by 2037. So every household within the country, every premise within the country has to be provide thermal comfort, some kind of cooling, so that people can live their life in a healthy condition. So the recommendations are divided for within, say, space cooling, where we have talked about how to use traditional practices, how to use passive cooling mechanism to reduce the demand of cooling, then how to use make highly efficient equipment affordable for the public, so that their purchases increase. At the same time, to support design of new cooling equipment which are affordable, but also able to provide the parameter of thermal comfort. Now, the parameter of thermal comfort for India would be around, say, 27 to 30 degree, within which people can live comfortably in a tropical region. So that within that band, so from 25 to 30 degree, if you can bring the temperature down within the closed premise and then run a fan, then you can stay comfortably. So those kind of recommendations.
Okay,
In
sir.
terms of, say, yeah.
Yeah, then there is a question that feasibility of district cooling with integration of cooling as a service. So what do you say about that?
So a number of studies had been done. Even we had commissioned study on this regard in partnership with UNEP in the past, and UNEP is also doing a lot of research in India. So what it says that for commercial, my personal understanding is that district cooling will work most in Indian perspective for commercial premises that might not be very effective for a mixed use where you have commercial and residential, mostly because of the way residential consumers use air conditioning. So good opportunity for commercial premises, but not so much opportunity for residential users in the country.
Okay, the last question, what software you would suggest for designing efficient green buildings?
See, I won't suggest any software per se, but there are different softwares, like the free softwares, like IFC has this software which is available, which anybody can use. Then there are also softwares which you can design softwares which are available. So I'm not going to recommend any of them. You can use like all of them have their benefits and restrictions. So there is nothing specific I would recommend, but just keep to the basics, that when you design a building, you need to understand that there has to be ventilation, there has to be shading. So these are the two very important and the component, and then you use materials which have a high thermal resistance. So if you just stick to these three basic component, you will end up designing a building which is uh, energy efficient, and you will use will have less energy consumption.
Okay, thank you so much, sir. Thank you, Mr. Sirvashi. It was a very nice presentation, and thanks for your time. There were many questions. It was so nice of you. Thank you again
Thank you,
on
sir,
behalf
for
of
giving me the opportunity, and look forward to the next presentation.
Thank you. Okay, so that was very nice of Mr. Shubhashish. Now we have our second presenter. We have Dr. Muhammad Adil, who is presenting about energy wastage and recovery options in buildings. Dr. Adil is Deputy Director and co-founder at Center for Industrial and Building Energy Audits at University of Engineering and Technology, Peshawar. He is also founder of Sustainable Housing Research Center at UET Peshawar and assistant professor at the Department of Civil Engineering. He's teaching since the past 16 years, and he has a PhD in sandwich building panels from University of Southampton, UK, and postdoctorate from Kingston University, London in the UK. So over to you, Dr. Adil. Dr. Adil? Yep, thank you.
Ji, Assalamualaikum, Bismillahirrahmanirrahim, and thank you, Dr. Tanveer, for introducing me and arranging this seminar as well. First of all, I would like to applaud all the audience who have taken great interest in this whole seminar, whole webinar arranged by SAARC Energy Center, considering the importance of the topic. Also, I would like to thank the SAARC Energy Center as well for arranging this seminar or webinar on a right time when it is there is a need, and there are so many technologies now available almost at the hand of the people who are in need and people who can actually use them, and so that they can get aware of all these. SEBIA is the Center for Industrial and Building Energy Audits, and which has been established about 2 years ago with the help of Higher Education Commission at UET Peshawar. And we are just celebrating our second anniversary at the end of this month. In my presentation, before we take all questions and answers, I'll introduce SEBIA first of all, and then in coming 20 slides, I will try to clear the concept of building energy wastage, which is a relatively different way of seeing it. Then, in order to understand it more clearly, what SEBIA has done is has done some real practical work on measuring and taking care of the wastage issues in Peshawar city related to building energy. So we'll talk about two case studies here. One is for a commercial building and the other is for a residential building. And in order to understand the gravity of the energy wastage issue in a specific building, we have adopted building information modeling as a tool to study in detail the energy wastage in a building, and then try some or experiment on some techniques to reduce that without actually practically implementing it, but actually using the computer environment, simulated environment of a building, and then doing some retrofitting on it to see what kind of retrofitting can be more will have more potential in reducing the energy wastage in that building. So I'll be more technical today, so that it might be boring, but I would like to keep myself entertaining as well. First of all, our team, we are a very diverse team of from field point of view. We have the Dr. Irfan Mufti is the CEM, Certified Energy Manager, who is actually directing the whole SEBIA company under UET Peshawar. Few of us, including myself, are going to give their lead Green Associate and lead AP exams for building design very soon. We have electrical engineers, we have mechanical engineers, marketing experts as well. And this team all together sees both the industrial and building sector. But because my today's presentation is about building energy, so the specific team that work on building side is myself and engineer Amar and engineer Inam, along with engineer Adit. And this work that I'm going to present today has been worked by this team. Our company SEBIA has several state-of-the-art latest energy auditing equipment, which I've listed here on the right side. And the most important thing related to buildings I want to highlight today is the blower door, which is shown on the left here. I'll go and talk about blower door a bit more, but this is, to my knowledge, is the only facility in Pakistan to test on real time a building for wastage of energy through leakages in the buildings, and how important they can be, how much serious is energy wastage issue when it is connected to the different types of air leakages in the building. We'll talk about it in a while. Before we go and discuss a blower door and the BIM implementation and in controlling the wastage of energy, let me clarify and or actually discuss some very important statistics that we commonly deal with all the time around in Pakistan, also around SAARC countries, and even around the world. Both Dr. Subhash and Dr. Tanveer have talked about the building sector's demand on energy in India and in general as an average, but it is also important to note that this changes from place to place quite a lot. At the whole country level average can be a misleading one as well. For example, this study being done in Punjab area suggests that about 52% of the energy is consumed by the building sector, which is the sum of the both commercial and residential building sector. So the Dr. Tanveer and Dr. Subhash were talking about around 30%, a bit more than 30% of the demand from this sector. But then we have to be careful, and we have to go on a much micro level and see the demand, local demand, and then accordingly select the sector to deal with energy conservation measurements. So I will, for my presentation, I will stick to the 52% demand from the building sector, but I also admit that the global average for a country, or maybe for SAARC countries, remains to be around a bit more than 30%. From specific to Pakistan, some statistics, about 73% of the population of Pakistan has access to electricity, which is also increasing day by day. This is the actual calculated or measured one, but then also connected to that are some theft and losses of some other types of infrastructure type as well, that actually make energy available illegally to other people as well. So on ground, maybe more than 73% of people have legal and illegal ways of having electricity, but then this is the calculated and measured one. About 25% of this electricity is lost due to technical reasons or due to theft reasons as well. Technically, it can be losses, line losses, and so many other things as well. So this is a thing that government is in Pakistan is trying to control by connecting it with load shedding. So those areas where there is a theft issue, and where the people are not using energy efficient equipment, so that in their houses they get more load shedding in high demand periods, but then that is also something that changes time to time. The important point from my presentation point of view is something that we don't know, we haven't measured yet, is that how much energy actually we are wasting at consumer end. This is analogous to wasting water. So what we are doing it, if we are wasting energy at our homes, specifically electrical energy, then the electricity or energy provider has to provide more energy, like more water, in order to fulfill the demand of the whole community. So by wasting energy, we are making a huge load on the electricity or energy provider, who have to fulfill the demand of the whole community. So if we reduce this wastage, then that energy will become available to other people, and the load on the energy provider will definitely reduce, because already the community is fulfilled with their energy needs. As I mentioned, energy efficient equipment do exist, and they are being used in Pakistan for a while as well. And a couple of years ago, when we had the energy crisis, solarization became very common, and beside energy efficient equipment that runs on alternating current, now we have DC equipment available as well. And we have now air conditioners commonly used which have inverters in them, so they can run maybe on solar as well, but they are also energy efficient, a bit expensive, and also inefficient equipment is we have seen in DC as well, of low quality fans and other similar equipment. But then of course whatever public can buy and what is that makes the demand, and this is how economy runs. So that also has affected the market, energy sector market of equipment in Pakistan. But here in this specific study, I want to show that it's specific to cooling demand. The blue bars here are showing the typical residential baseline, but if you use energy efficient cooling equipment, we can actually save more than 33%, but the least we are seeing in this graph is a 33% of demand has reduced because of selection of energy efficient equipment. But then this is not energy wastage. The purpose of showing this slide is to differentiate between energy wastage and saving energy by energy efficient equipment. It is not stopping the wastage of energy. So here again, I want to highlight that if the same energy efficient equipment is being used now for 24/7, what that will cause is will keep the demand on the electricity or energy provider. And actually we should create an environment from the building envelope itself that people would not need any more cooling after a certain level of cooling perhaps, or maybe heating in winter, and then that way they will turn off their equipment and then they will stop wastage. So that is the difference between wastage, and it is not same as reducing wastage is not same as saving energy. Also similar graphs are shown by Subhash as well in his presentation. This is also from the similar reference, perhaps a bit older one, that one shown by Subhash, for India as well. But then in Pakistan, we also, whatever we have visited the buildings, we have visited and studied through energy audit in Peshawar specifically, we also found it quite similar here, although these stats for India might have changed as shown by Subhash, but then specific to Peshawar, this is quite applicable. You can see on the left here, fans use most of the electricity because not everyone can afford air conditioning. So fans run, it's a concept of just blowing air around to cause evaporation on wet surfaces like human skin and cause cooling in that form. But then we can have air conditioners which are energy efficient, but in Pakistan it's hard to get fans which are any more efficient as what we can get in market. So replacing fans with energy efficient fan is not a sane way of dealing with energy efficiency when we talk about energy efficient equipment. There should be other ways of reducing the demand, and wastage control, energy wastage control is the thing that we have brought in through today's presentation. On the right side, commercial sector uses lighting as the most energy consuming sector. HVACs in Pakistan are not very common in commercial sector, but wherever they are in efficient form, most of the new places. but mostly split air conditioning is commonly not centralized, but split systems are very commonly used, and also they're not very efficient, efficient as well. So I'll keep the HVAC or split air conditioning systems as a second largest consumer of energy in commercial sector for Pakistan as well. This I believe same applies to hot SAARC countries as well, and in cold areas and even cities like in Pakistan we have much, and India as well, we have much very cold areas and very hot areas as well. So but there are some countries like Nepal where mostly it is very cold weather as well. So for that we should have a separate set of such studies. Still the question remains the same, that how much energy is wasted in or actually by building design. So the way we design our buildings, we actually make energy wasting machines, and this side of building design really need to be taken care of. In Western countries it is very common, and in most of the places it is by law to have an energy efficient design. There are so many LEED certified buildings around the world, but not so many in Pakistan. We can count them on fingers literally. um, so and this concept need a lot of awareness in Pakistan, and I believe in other SAARC countries as well, to have an energy efficient design intrinsically from the very start. And Subhash has given the example of the Gol Gumbad uh, structure. So yes, we should be looking at the building envelope to be already energy efficient. This is a bit analogous to wastage or solid waste management as well. Like we have energy wastage around here and there in the building design, and we have to manage it somehow to reduce it as much as possible. So in solid waste management we have concept of recycling and other as well, but the concept of reduction of waste really applies to energy wastage as well. So once we are clear about how different energy saving and energy wastage control are, let me introduce you with a blower door device which can be used to measure the energy wastage. And we have we have a calibrated whole kit of blower door system, which we have used on a whole single story and both residential and commercial buildings, but then it can be used for multi-story buildings if there are split air conditioning in the rooms. So we can also do testing with this one kit, but then for bigger buildings with HVAC systems, we need bigger blower door systems to measure energy wastage by leakage. So you can see this in this figure, that once we install the blower door on the building, we open all the interior doors if it is a centrally ventilated and air conditioned building, and then usually we depressurize or suck the air out from it, and we keep it up to 50 pascals of negative pressure inside. So what happens is, because of the negative pressure in the building, from all the nooks and corners where there are gaps, holes, openings, cracks that can leak air in or out, will start sucking air inside. And with the controlled flow of air, we can easily measure what is the air change level, or in other words, the leakage level or infiltration level of the whole building. So if it is if it's not a centrally air conditioned building, then the same test applies to each and every room where we have split air conditioning systems, either for heating or cooling. And for every individual room, then we measure the leakage rather than for the whole building at once. So the test also can be performed by pressurizing it, by pushing air in, and by ASTM and international standards, it's actually advised to perform the test twice in both pressurized and depressurized form. But at the end, what we get is the level of leakages in the building. So what we are doing is in summer and in winter we are cooling and heating the building, but there are so many leakages around the building, and if specific to if it is specific for a room, then leakages in a room that are not letting the air conditioning system to trip by the thermostat system, and that keep using the electricity. And that's how electricity, or maybe if you have a heating system that runs on gas, then gas wastage as well. And so blower door test can really measure one way of wastage of energy. Now you might be thinking that is the air infiltration or leakage is so big that it can really cause a lot of energy loss in terms of heavy bills. So let's see so the results of some of our studies. This is a test we performed in one of the commercial buildings. Our team was installing the door there on one side on the left, and on the right side one of our team member, engineer Nam, is taking data from the blower door that tells the leakages in the room in which he is sitting already. So this is the first case study of a commercial building. I'm calling it commercial building A for reference purpose. There are more than 16 rooms in this building. A few of them are offices, but the 16 rooms are big rooms, and they get occupied by around 40 people at a time. So there's a demand of circulating air in both winter and summer at a time. So we performed, because air conditioning is specific to this building, was not central, but every individual room had split air conditioning systems. We performed blower door tests on every individual room here, and once we performed it, we got a result which is something like this. I would like you to concentrate on the third column here, which says air change at 50 pascals. This is something reading we get which tells us about the leakages. So from international standards, or specifically from ASTM standard point of view, a typical residential or a commercial building should have a ACH value, or air change 50 value, not more than 3. But you can see in this building the number is much larger than 3 units. It is about 13.98, and in some locations it is 15 as well, and 17 too. So this tells that our buildings, already built buildings, have not been sealed properly, and because of that, indeed there is a lot of air leakage, and that cause a lot of energy wastage. But then how much, that we have calculated, and I'll tell you after a while. So I'm not going in detail of all of the columns, but this was the important point that I wanted to highlight here. So after performing the blower door test, the ACH 50 value that we got for that building was one of the maximum value was 13.2, or actually it is the average of for all 16 rooms in that particular building. We used climate factor to convert it into a natural form. The climate factor for this particular building was 9.71, and that converted the ACH to 1.36 once the blower door is not installed. So a typical building is in common normal days, it is in use with a certain air pressure, and because of that there is a level of leakage in the building. So with blower door, because we have hugely pressurized or depressurized the building, we get very high ACH values, but we can convert them into normal day ACH as well. So without pressurization, if there is any leakage going on in the building, that will be to a level of 1.36 for an ACH 50 of 13.2. And this number seems to be this is the number which we should be careful about not comparing with the ASTM lower limits, because ASTM lower limit is on ACH 50, which is a test blower door test reading, not the converted one. But why we converted this in value into normal days? Because we wanted to simulate the same commercial building on building information modeling tool. And once we simulate that, we need to simulate for it for 365 days of the year. And in those days, blower door will not be installed there. So it will be in natural windy or non-windy environmental conditions. So in order to simulate that, the ACH 50 is not used, but climatically converted ACH of 1.36 was used for that. And we created, on the basis of that, we created our building information model. The model was for this particular building was easy to build in a way that it was just renovated last year, and then we already had the BIM model, architectural and engineering, structural engineering model available to us, but it was never used for energy analysis. We used the same one and modified it with some measured and energy audited readings we took from different parts of the building, and we actually did the heating and cooling simulation of the building. We also tried to do the solarization analysis of this particular building as well, and just to reduce the demand. But then that is a separate issue for today's presentation point of view. My main concern is the picture on the left here, which is the heating and cooling load analysis. So I'm not going in detail of the model, how we did that, what are different parameters, but I'll directly take to the final results. The orange portion on the top here is the list of results from the blower door test data, that how much heating and cooling load is on this building. So what we did was we applied the ACH or the air change of 1.36 to this model, BIM model, and we simulated it for 365 days to figure out how much heating and cooling is required. And if you look at the number on the top, it is about 0.413 million BTU per hour. The third number is 0.111 million BTU per hour. These are both heating and cooling loads. What we did was we then in the simulation to our building, we knew already from our blower door test where are these cracks and gaps and openings where this leakage is happening, and we just closed those openings in our model and brought the ACH from 1.36 to 0.52, as we can see in the green area at the bottom. So by controlling that in BIM simulation, we did several trials to figure out which one is more effective, and then at the end, once we achieved a 0.52 ACH in natural climatic conditions, we found a drop of peak cooling load and peak heating load, which are the first and the third reading in the green table below. And this was about 12 to 20% reduction for heating and cooling. Sorry, it's actually more than that. I'll go in detail and talk about that in detail in a while, but then we can see a significant drop in energy demand for heating and cooling both. The second case study here I want to discuss is for a residential building. We selected in Peshawar, which was a 2-bed, 1 drawing room building, a single-story small house, about 167 square feet area. And after doing the blower door test on it too, we found the ACH 50 was 34 for that, much higher than the commercial building. So this tells that the typical residential buildings that we have already built around Pakistan, we haven't taken care of leakages at all in them. It's a huge number compared to the required standard number around the world by STM or other international standard as well, ISO as well. That is just around 2, 3 or 5, depending upon the purpose of the building. and then applying the climatic factor to it again, we got this number dropped to 2.38, which now can be used for simulation of this building. And then we did a full 365 days of full simulation of the whole year on this building. And after that, the results similarly we got. On the upper part there, we can see comparing it before any retrofitting, virtual retrofitting, and then after virtual retrofitting of bringing the ACH to 0.52 from 2.38 for this case, we see a significant drop again in heating and cooling load of this building as well. To summarize both these case studies, in residential building, we found that for cooling, we have dropped the cooling demand by 25%, and the heating demand is reduced by 21% in residential building. And in commercial building, the heating demand reduction was much higher. It was about 32%, and the cooling demand was reduced by 12% actually in commercial building. So at the whole summary of all my presentation is just this one slide, which says that if we combine blower-door audits with the building information modeling for new designs or even for existing buildings, it is possible to reduce 12 to 32% of the energy wastage in both heating and cooling. But if you talk about the whole combined energy sector, including industrial and everything, the whole demand on the energy sector of Pakistan, if I talk about, by considering the same 52% country demand of the building sector, but actually including the industrial sector as well, we can reduce from 7 to 17% the energy demand on the whole energy industry in our country. And that was the whole point of my presentation, and it just give us a hope that we can not only reduce the energy load by doing a simple blower-door test and use latest building information modeling methods, but also we can give a very comfortable and easy to live clean environment to the residents of these buildings, either commercial or residential. And this concludes my presentation. And thank you very much. If you have any question, I'm all ears.
Thank you so much, Adil Saab. It was a very nice and informative presentation with facts and figures. Really found it useful. There are some questions, sir, for you. You mentioned the blower-door test for quite some time in the presentation. What is the cost of this blower-door test? Like if someone want to do it in their building, residential or commercial, and how long does it take?
Yes, the blower-door test for a single room takes around, for the duration, if we talk about, it takes around 1 hour. It does not include the transportation of the equipment at the site, and again all other setups. But then if we have the blower-door there and the person who is operating it there, so we can for a single room we can do it in 1 hour. But then if it is a single if it's a whole building which has centralized system, then we need to look for openings and gaps by using other equipment as well. Before we start performing this test, we have to do some other health and safety cares. That takes about 1 more hour for a small building. But for a commercial building, of course, that is a whole energy audit. So you can say it can be a part of an energy audit, so that will take the duration of the energy audit as it commonly happens. But if you are specifically talking about a blower-door test for a residential building, around 1 to 2 hours, and for a commercial building it can take around 3 to 5 hours, and we'll have the final results actually with us. The cost, we have a fixed cost of about CBA has its own cost of around 10,000 rupees, and then that's the fixed cost, plus with every increase in square feet from 5 marlas area, we have varying negotiable cost from the client. So it depends upon the owner of the residential building or the user of the residential building who is interested. So accordingly, we adjust that amount on it. Also, if it is an industrial building or commercial building, then we, depending upon the income level of that, we give them a discounted negotiable price above that. But there is a fixed price on that beside the transportation and
Okay, sir.
mobilization costs on it. Yes.
Then, sir, there is another question that you mentioned that 33% energy efficiency or energy that can be saved in the start of your presentation. So, what do
Yes.
you think? What would be the investment required for that, for the measures taken to save that energy? And do we have any energy efficiency financing scheme for investing that thing?
Right, there are two questions. So that particular research that I've shown you, of course, this whole presentation will be shared by Dr. Tanveer to all the audience as well. So you can take the reference from there. But that particular research was on a building where they have tried to replace the lighting, heating, and cooling equipment only. And with the combined effect, it was 33%. The typical air conditioning system and typical heating systems and typical lighting systems that we say CFLs and other incandescent lights, which are commonly which were commonly used in Pakistan, you can say around 5 to 10 years ago, still in common use in so many places. Comparing that with the latest technologies, like we have LEDs in lighting, and then we have inverter air conditioning systems, nothing much in fans, but then yes, covering all those things. And then we have heating systems with gas plus electric systems. That was compared with that, and with those equipment which are now readily and commonly available in market in Pakistan, this was the result that has been observed. So the cost, you can say that whatever is the cost of the energy efficient equipment in market nowadays in Pakistan, that cost you have to bear. So that will be the cost. I cannot give you a sharp number on that. And
Okay.
the second question was about the second part of the question. Tanveer, can you remind me again, please?
Financing opportunities available
Yes.
in Pakistan.
Thank you. Thank you. NICA is the government organization which is working on energy conservation in Pakistan. They are working on making these plans, and in some of the cities like in Islamabad and Lahore, they have schemes for net metering and similar as well. They are going to they are nowadays having very rigorous meetings on such type of topics, and I hope soon in this year they're going to announce some financing schemes. Even this is from the government, and I hope if private sector partner with them, which I believe they will, there will be some more similar financings we are going to see very soon in Pakistan.
Okay, Adil Saab, some questions from one of the participants from New Jersey. So he has 2 or 3
Yes.
questions. What some simple steps would you recommend for reducing the energy consumption without affecting the overall like comfort level, you can call it, in the building?
Okay. Right. There are 2 things, and if we talk about Pakistan, we really should be talking about both of them together, but then we keep them very separate. One is energy saving and other is comfort level, and I'm glad you asked this question. We have to combine both of them together. So what I introduced you, which you already know about, is building information modeling. We have several free and proprietary tools available in the market. I believe if you use building information modeling for energy simulation of your building, you will be shocked that there are interventions that are very commonly talked about in energy saving, they may have nothing to do with energy saving in your particular case. In some other buildings, maybe it will be effective, but it may not be effective in a specific other case. So we cannot list and give you a list of one set of things that these are the things, if you take care of, your energy, your building will be energy efficient, and the comfort level as well will be maintained. So if you have to do the simulation, and like I've shown you for 365 days, and you will see that even if there is a tree outside your building which is causing a shadow on your building, the comfort level is already maintained perhaps in one of the rooms of your building, which may not be the case in other building where there is no such tree on that particular corner of the building. So I would suggest, instead of going for a list of things that we can do for saving energy and at the same time achieving the comfort level, do these energy simulations and pick up the most effective ones and most comfortable ones and implement them, which may be different from building to building. This is what I would suggest.
Okay, you mentioned that, but I will ask again another question, that are there any considerations for payback period when conducting energy efficiency in buildings?
Sorry, can you repeat what you said about the periods? Which periods?
Uh, are there any considerations for payback period while designing energy efficient buildings or conducting energy audits in energy efficient buildings?
Well, yes, again, it changes from case to case quite a lot. In maybe after BIM modeling and analysis, you may get a result that you don't actually need to do something very big, like changing your air conditioners or so. Maybe it's just applying some shades and covering your roof with some insulation may be enough, and your other existing equipment will be fine, and it will automatically start tripping and start saving energy, which is not happening recently. So it can be a very different scenario again. And that may be done with very cheap methods, or like the example I gave you, or maybe in some cases, like in commercial buildings, you, instead of installing individual split ACs, installing a whole HVAC system with some specific cooling techniques may be the final solution, and that can be more expensive. So again, this is something that you should calculate, and don't stick to only one option. Look for multiple options of energy saving and creating more comfort in the building. And if you do so, then you will be able to choose the right one. Again, at the end only you will be able to compare the payback periods, because technical issues should be addressed first and then the financial issues. So I will again I will not comment on the period itself, the payback period itself, but I will suggest to use building information modeling tools to actually look at different options, and then they will tell you that which one is having a least payback period, but maybe it may not be very comfortable. So that is something you would like to have. So you may go for a more expensive and larger payback period projects too.
Okay, and based on your experience and research, is there any software that you would like to recommend for energy efficiency studies in buildings?
I'll stick to the Subhash policy again, not to name any. There are so many software available for this. But what I want to tell is that, to my knowledge, not all the software give you the final result. So you need to do some calculator work at the end as well in order to come to the final decision. Because these, for example, one of the software is built for US energy department, and it deals with buildings that are built in US. But in Pakistan, we have a very different type of buildings, very different stats here. And if we use the same software, that will give us the results for the type of buildings or the environment of US, and there are standards and constants that are mentioned for that environment. So we should convert them, like I converted ACH 50 to normal ACH. So we should be careful about using this software.
Okay, sir. There is another question, sir. Is there any material specifications or traditional material with value-added chemical alterations that can be used for energy efficiency in buildings?
Yes, if you see the history of mankind, in fact, after getting out from caves and constructing houses from trees and then stones, we see a long period of using mud and mud construction around. And in one of my companies called SHRC.com.pk, which is Sustainable Housing Research Center, we research on mud, and we found remarkable results in energy efficiency in terms of heating and cooling. Once we use mud, we have modified mud with in different ways, because one common way of modified mud is common brick. We just burn it to make a block and then use in construction, so it changes its properties. But we have observed that in past, mud was used without cooking and without burning in the kilns. So we started to use chemical binding, and we discovered that in nature it's porous, and its pores give a very unique energy efficient results. But then it is weaker for construction, so we have combined it with some other technologies like sandwich panel technology, and we are working on it. If you're interested, I would love to share the results of that study with you as well. So I've named only one, but of course there are other polymers and other materials as well.
Okay, sir, we are running out of time, but three quick questions. What is the cost of blow door equipment? Like if you could specify it in dollars.
Yes, it's about for us with the taxes and all, it costs around $15,000 to us for this one with one fan. But of course, if you talk about bigger buildings, you need more fans and more manometers with it. That will really multiply the cost. So this one kit is of about $15,000 is enough for small residential buildings, and also for both with HVAC centralized systems. But if there are split systems like we have common in Pakistan in even large commercial buildings as well, then we can do all these tests with this single fan system as well. But if it is a bigger building with centralized system, you need more fans, and that's more costlier.
Okay, so there are two more questions. How is it only like the technical things that we should focus on, or the human behavior? There should also like be more focus for energy efficiency in buildings.
You're right. The human behavior is also very important, but thanks to the thermostat technology and light the usage building usage detectors, that it automatically turns off the lights for us. It is nowadays automatically turning off the air conditioning for us as well. So there used to be in Pakistan TV channels and other places as well, there used to be campaigns for stop using the lights in the morning, and so many other similar ads we used to see. But with the automation industry on its boom nowadays, I think it's well in control of these robots now.
Okay, so the last question is from Mr. Shubhashish De, and he's asking that how common is usage of BLDC fans in Pakistan? As the BLDC ceiling fans, they consume almost 50% electricity in comparison to a regular fan. So any idea about that?
To my knowledge, I'm sorry, I don't have that knowledge. But then the ceiling fans, I didn't find any being used here, any different technology except the DC fans there that are used here with the solar panels. So because they are always connected with solar panels, so their consumption, we cannot just say that it is a load on the electricity provider. So it is, I will say, the DC fans are 100% efficient in a way, if we talk about that in context of um, energy provider, no load on that. Um,
Thank you so much,
I
sir.
may
Thank
not
you so
comment anymore.
much.
Thank you, Tanvir, and
Okay.
everyone for being here all the time with us. Thank you again.
Thank you, Mano sir. Okay, so
Thank
now we
you.
move on to our third speaker, Dr. Guju Li, who will be talking about development of green buildings in China and main technical standards in his presentation. Dr. Li is working for China Academy of Building Research and is the Deputy Director of the of the Institute of Science and Technology Research and Development of this organization. He has led and participated in over 10 projects funded by the China Ministry of Housing and Rural Development, Ministry of Science and Technology of the People's Republic of China, EU, Global Environmental Fund, and the Energy Foundation. He has published over 15 specialized technical books. Besides, he is the main author of 10 China national standards, local standards, and group standards. His work has significantly contributed to the transition from conventional building to green buildings in China. Over to you, Dr. Li.
Okay, thank you. Let me confirm, can you hear me clearly?
Yes, we can see. Yes, we can see the screen now.
Okay, thank you again. Thanks for inviting me to have this opportunity to share something about the green buildings in China. And my topic is the development of green building in China and the main technical standards. Just as the host introduced, I'm working on the green building in Israel and for 5 years. And today I want to share something, my knowledge and the developed status in China of green building. And before my presentation, and please allow me have a brief introduction of our academy. China Academy of Building Research was founded in 1953 and now is the largest comprehensive research and development institution in the building industry of China. And there are 4 main business for CABR. The first one is to carry out common, basic, and public technical research to put forward solutions to key technical problems. And the second, CABR develop and manage main technical standards and codes, especially the national standard and the industry standards in China. And the third, about the quality supervision and testing. And the fourth one is to develop new technologies and products and provide some service to other institutions. So this is the main business of CABR. Okay, let me start my presentation. And my presentation is divided into 5 parts. And the first one is the overview of status. Actually, I mean the green development of green building status. And in recent years, practice of green building in China is steadily promoting. And the left figure shows the number of green buildings in China. And at the same time, the whole society has gradually improved the concept and understanding the green building. So it's another way to promote the development of green building. The number of green building goes up rapidly year by year, and our national standard, assessment standard for green building, issued in the year of 2006, but till the 2008, we have 10 projects, 10 green building projects. But till now, as the year of 2017, a total of more than 1,000 green buildings have been certificated in China, and all these buildings certificated by China national standard, and with the area of more than 1 billion square meters. And as of the 2018, the total area of buildings in China reached 2.4 billion square meters. And in the same time, the green building accounts for nearly 60% within the whole new buildings. And then this is the numbers of green buildings in China. And from this practice, actually, we choose 200 green buildings projects to analyze the operation date, and we get the benefits of green building shows here. And the average ratio of energy saving reached nearly 60%. Of course, it's all existing building, and different building has different level for the building. So the energy saving is the ratio of energy saving is different. And the average ratio of green space is nearly 40%. The average ratio of water saving is more than 15%. The average ratio of recyclable materials utilization is nearly 8%. And the average carbon emission reduction nearly 30 kilogram per square meter. And this is the benefits. And since the 1980s, in China, we start to promote the energy saving building. And energy saving or energy efficiency is just the single attribute or single features of building. And from the 2005, we start to promote the green building. And the green building, as we know, is overall attribute of buildings. It includes not only the energy, but also the water, the materials, the land, and so many attitudes. So it's overall attitude. And since the year of 2010, we start to promote the green eco district or green eco city. Actually, it's a city attribute of buildings. So from this process, we can know in China, we expand the green development scope from a single building to a district. And the second, the sustainable development covers the buildings and cities. And nowadays, almost all the buildings in China still meet the requirements of green building. I mean, the new building meet the requirements of green building. And in my opinion, the promotion of green building in China is very successful practice, and with a lot of work. So maybe someone may ask, why is the development of green building in China so fast and sustainable? And how does the green building development grow? And what has been done to promote the development of green building? So I give a brief answer. The first, the policy support is the driving force. The technical research is the guarantee. The improving standard system is the basic, and the certificated project is the experience source. That's what I want to share with you today. First, let's talk about the policy promotion. Leaders value green development in China. Now, according to the speech delivered by Chinese President Xi Jinping in the World Climate Change Conference 2015, he said, develop green building is one of the ways to form a new pattern of the harmony between human and nature. It shows our leaders very pay attention to the green development and green building. And if you listen to the international news, you may know there are 5 development vision in China. They are innovative development, coordinated development, green development, open development, and shared development. You can see the green development is one of the 5 development vision of China. And another one, there are architectural principle in China. It's guide the building built. So in the new architecture principle of China, green is one of the principles. The 4 principles are applicable, economical, green, and beautiful. Green is one of these. And here shows some national policies in China. Of course, these policies in Chinese, but I mean from the year of 26 till now in China, lots of policies released to promote the green building. It not only include the science and the technology, but also some national plan or the green building plan or an urbanization plan. All includes the green building. And especially I want to show you some policy. In the national midterm and long-term science and technology development plan, in this plan, it put the building energy saving and the green building as the important area of the urbanization and the urban development. And we will promote the sustainable development of China through the realization of green building. According to this policy, many technology research projects conducted to promote the development of technologies. And the second policy is the National New Type of Urbanization Plan. It shows the green building, promote the green building, and clearly point out the approaches to speed up the development of green city, including 4 aspects. First, to implement the Green Building Action Plan is also a policy in China. It's especially for green building. And second, to improve the green building standard and the certification system, extend the scope of enforcement. And this policy is released in 2014, and in this policy, we will to improve the green building standard system. And the third, to develop the green building material. The green building material is also a very important part of green building. And the fourth one, to fully implement green building requirements and certification. And another policy is the 13 5-year plan for development of building, energy conservation, and green building. And in this policy, point out that the amount and the quality of green building improved at the same time. Just as I mentioned, the number of green buildings increased year by year, and till now maybe more than 10,000 green buildings. But in the next stage of the development in China, we want to improve the quality. So this goes point out. And another goes, by 2020, the proportion of green building in urban new buildings exceeds 50%. And during this period, the percentage of 2 stars and 3 stars green buildings exceeds 80%. And the percentage of projects reach in green building operation level up to 30%. It's the goal of the development of green building. And third, I want to share you the standard system. The most important standard to get the development of green building is the assessment standard for green building. This standard plays a significant role in the promoting green building in China, because the definition, assessment index, and the assessment method of green building are clarified in this national standard. And based on this standard, the standard system of green building in China has formed and goes towards a refined trend. And here shows the green building standard system. It covers the whole building life cycle. For example, in the design stage, we have two standards. The one is the code for green design of civil buildings, and the second is standard for green performance calculation of civil buildings. And in the construction stage, we also have two standards. The first is the evaluation standard for green construction of buildings, and the second is code for green construction of buildings. In the operation stage, there are two standards. The first is the technical code for operation and maintenance of green buildings. And the second is standard for test and assessment of green light. And in the retrofitting stage, also two standards. The first is the assessment standard for green retrofitting of existing buildings. And this standard is especially for the existing building. And the second is the technical standard for green retrofitting of existing community. And in the assessment stage, there are many assessment standards. And here shows the assessment standard system. It covers the new building, the existing building, the industry building, and the area. Now let us see the new building. In the new building, except for the assessment standard for green building, it also has the assessment standard for green office building, for green store building, for green hospital building, for green hotel building, for green museum and exhibition building. And in the existing building, as I said, there is one standard, is the assessment standard for green retrofitting of existing building. And especially, we also have the assessment standard for industry building. The industry building is very special from the civil building. We have this standard, assessment standard for green industrial building. And also we have the standard for the area. The one is for the green eco district, and another for the green campus. And all of this is the assessment standard system. And except for the national standard and the industry standard, in China we also have local standards and group standards. For local standard, it means different province or different cities have different climate, different economic, different development level. So different city or province allowed to develop their own standards according to their regional features of cities. So this is the local standard. And the group standard, it means academy group, such as some organization, association, and islands be allowed to develop standards to fill the blank of national standards and industry standards. And this is the other standard. And local standard and the group standard also is the standard system. So in the first part, I will give you an introduction of the latest standard. And just as I said, the assessment standard for green building is the most important standards in China to promote the development of green building. So there are 3 vision and 2 revisions process of this standard. It means we issued this standard in the 2006. This is the first vision. After nearly 7 years, we have some experience of the green building. So I want also we find some problems during the project, during the development process. So we start to revise this standard. And the second vision of this standard issued in the year of 2014. And based on the same reason, we start the second revision and the third vision of this standard issued in 2019, last year. It's the latest standard. And I will introduce some background of this revision. We want to review the standard. The first reason is to meet the people's ever-growing needs for a better life in the new era. It's the first reason. And the second, to meet the new demands of green building in the new era. There were 3 reasons. First is to follow the new technologies and the concepts in the building industry. The second is to innovate green building assessment technology index system. The third, to meet the high quality development demands of green building. And another reason or another background, we have found some problems during the development of green buildings. And here shows the problem. The first is we have more design levels and less of operational levels. It means most of the green buildings just in the drawing. But when the building construction or complete the construction, some knowledges may be not used in the project. So it's lack of the actual effects. This is the first problem. And the second problem, people-oriented requirements are not enough because for the green building, more requirements are required for the performance of building itself. For example, we want a building have a high performance of the insulation of wall. We want a building save materials. We want a building save water, and so on. So all the requirements just for the building itself is not consider the people in the building, the feeling of people in the building. So it's the second problem. And the third problem is poor response to the new technologies and the concepts under the fast development of building industry. Just as I mentioned, the different vision of standards maybe have 5 years to develop. So during these 5 years, maybe a lot of new technologies, such as the beam, the health building, the passive house, and so on. So it's a poor response to the new technologies. And the fourth problem is the perceptible requirements needs to improve to let occupants feel the benefit of green building. It means the green building, not only to save money or save energy, save water, it can give a better life. For example, it can bring a health environment, a comfortable environment, and high quality. So we should let the occupants to know the benefits. So this is all the 4 problems, and so we want to solve this problem. I do some works, and I will share some revision highlights with you. The first one, we built an innovative assessment technology index system to meet the people's need for a better life. In the formal vision, the year of 2006 and 2014, they focus on the 4 saving and 1 environmental protection. It means they focus on the building, on the land saving, energy saving, water saving, material saving, environmental protection. So as the occupants just know all things saving, but they don't know what else for them in the green building. So after we review in the latest vision, there were 5 performance changes. They are safety and durability, health and comfort, occupancy convenience, resource saving, and environment livability. It's the assessment index system. So in the new system, as the occupants, they can know, or green building can bring them so many benefits. They can provide the health and comfort environment, give environmental livability. So it's so perfect. And here shows the details of this index system. For example, in the safety and the durability, have safety and durability 2 chapter. And in the health and comfort, divided into 4 parts, includes the indoor air quality, water quality, sound and day lighting, indoor thermal environment. And in the occupant convenience, it includes the transit and accessibility, service facility, intelligent operation, property management. And in the resources saving, it includes the land saving and the land utilization, energy saving and energy resources utilization, water saving and water resource utilization, material saving and green materials. And in the environment livability, it includes the site eco and the landscape, outdoor physical environment. So here is the one highlight for the revision. And the second, we changed the assessment stage and it has the practical impact. In the 2014 vision, there were 2 assessment stages. The first is the design assessment. It means if a building complete the review of construction drawing through the certification, they may get the green building design label. But it just in the drawing. It doesn't mean when the building construct all the technologies can use in the actual building. And another stage is the operational assessment. And this assessment, it means if a building operation for more than 1 year, they can through the certification get a green building label. It's the real. Actually it's the real building get a real green building label. So this is the problem I just mentioned. We have many buildings in design assessment. Actually, we don't know the real effects. So in the latest version, we change it. The assessment of green building can only be allowed when the building project passes the final acceptance, and the design assessment is cancelled. It means the building just only can be certificated as the green building in the when the construct complete. And the aim of this change is to promote the implementation of green technologies and improve the practical effects. And the third, we add green building grade to promote popularization of green buildings. In the formal vision, just 3 levels or 3 grades for green building in China: 1 star, 2 star, and 3 star. Totally 3. But in the latest vision, we add the basic grade, and so now there are totally 4 green building grades. If all the requirements of prerequisite item are met, it is the basic grade green building, and the prerequisite items will write into the mandatory energy code of China. It means all the new buildings must meet the requirements of the prerequisite items in the green building. So as to promote the popularization of green buildings and to achieve the goal of all the buildings are green. So we use this method to promote the green building, and all the green building is the basic grade. And the fourth highlight is we set 4 requirements for 1 to 3 star green building to enhance the green building performance. If a building wants to get the 1 star, 2 star, or 3 star, they may meet the 4 requirements. The first is the lowest score for each index. The second is all the star green buildings shall be fully decorated. And the third, they may meet the score of 60, 70, and 85 respectively. The fourth, to meet the additional requirements in aspects of building envelope thermal performance, sound insulation performance, water saving efficiency, indoor air quality. So it's very strict for green buildings to get the star. So by this method, this approach, we promote the green building from the numbers to the quality to develop. And the last part is some prospect. And the first, as we know, the COVID-19, the virus, the epidemic, break out all over the world. And we also conclude some benefits of green buildings in the fight against virus. And our conclusion is reported by the World Green Building Council and the International Union of Architecture. They affirm the contribution of our national standards in the fight against this epidemic. So due to the time, I think I have no more time to make the detailed introduction. So if you are interested in it, you can search the internet for the documents for the news. And there are 5 parts, five aspects. And also, we also think what's the next stage for development of green building. Now, just as I said, in the near future, maybe 1 or 2 years later, all the buildings in China, all the new buildings in China is green buildings. So I just think what to develop next. And there are heritage in China is Health China. It's one of strategies on China's development, and we think a healthy building which focus on the health of the people in the building, and it's not only one way to respond the Health China strategy, and not only, but also it's one of the development branch on the basis of green building. So we have do some works on it, and we also develop a standard named Assessment Standard for Healthy Building. It's released in 2016. And all above is what I want to share with you. And here is my information, and my email is in the screen. So if you have any further questions, you can send me email. And I hope in the future we have chance to cooperation on the technology or on the international standards and so on. So this is my presentation. Thank you.
Thank you so much, Dr. Lee, for the wonderful presentation. First of all, I have one question. The standards that you mentioned throughout your presentation, are these available in English language as well? Like the translation, is it available in English language as well? Or is it only in Chinese?
Yes, it is a good question. And all these standards in Chinese, but just I said, we have the most important assessment standard for green building. This standard, we have the English version. And if you are interested in it, I can send the PDF version after the meeting.
Okay. The next question is, what political instruments are used by the Chinese government to promote residential green buildings? Like, is there any policy or anything by the government, by the provincial government, for promoting green buildings?
Yes, actually, the promotion of the government play a very important role in the development of green building in China. Just I show you all the policies is about actually is issued by the government, and the different parts of government department has do the same thing to promote the green building. And of course, it includes the public building, includes the residential building. So just as I shared with you, the policy is very important, and we do all the work and all the development all based on the policy, and it's the force to our researcher, to all the people to promote it. So national policy is very important.
Okay. And the next question is, are there any economic incentives for people who adopt these green buildings? Like, do they get any economic financial incentives to make it effective?
Yes. The first financial support is the one of the ways to promote the development. And for different cities have different financial support. For example, in Beijing, if one building gets 3-star, the government will give some money to encourage it. And in other cities have the same policy. Sure, is one of the methods to promote the development of green building.
And is there any financial assistance available to Chinese people for whom it may be difficult or not viable to adopt green buildings? So is there any financial assistance available from the government? or any other organization?
You mean the financial support from government or
From
whom?
government or maybe any agency?
Maybe what?
Financial, like any donor agency, maybe like for example the UN, EU, USAID, or
Oh,
anyone else.
okay, I understand. All the development of the green building actually is China's action. And we have some other cooperation project with another countries. For example, the EU, and it's supported by our science and technology department of government. Of course, the foundation or the money has to give to the China side, and the partner of the other countries maybe can apply the support from their own countries.
Okay. Okay. There is one question that is it possible to develop sustainable, eco-friendly, smart technology construction within the framework of social policy, and how can green products and green practices compromise the indoor air quality of a green building?
I just hear clearly the last question. You mean the indoor air quality?
Yes, how it can be like improved.
Oh, okay. As we know, the green building is a comprehensive concept. It's a big concept, and the indoor air quality is one concept of the green building. Now, for indoor air quality, in China we have another standard to require the indoor air quality, and in the green building we shall match the standards, the other standards in China.
Okay, okay. And the last question is it possible to develop sustainable and environmental friendly construction with the concept of smart city, green building policy given for the low income citizens, like people with the lower financial profiles? How would you develop like a sustainable construction or housing society for them?
That's a good question. I think every country or each city have their own features. I just share the development, some policies and the numbers in China. So in the places you said, I think it develop the green building step by step, and I think it's don't need to copy the experiments of China, but China's experience can as a reference, and I think firstly I think we can develop some standards for the reason, and I think it's not it's need to develop the green building so fast. We can develop it step by step, but I think it's possible to promote or
Okay.
develop the green building.
And is the implementation of these standards mandatory?
Sorry, pardon?
Does government make it mandatory to implement these standards, or is it optional while constructing buildings?
Actually, this standard itself is the you can building you can is the option one. Actually,
Okay.
is the option one. But in China, we just as I introduced, we want to promote green building, and the green building is very, very, it is a trend, not only in China, but also in the world. So it's now actually it's mandatory for all the building, and maybe in the 1 or 2 years later, all the new buildings must meet the requirements of green building. As I introduced, we add the basic grade, so all the buildings meet the basic grade, but it means it is not used to certificate as the star green building, but they must meet the requirements of the prerequisite items in the green building.
Okay, one last question, that what were the methods used to assess people needs for a better life? What kind of research was conducted to determine these needs? For example, was any survey done, or some interviews, or some questionnaire was designed? So how did you assess like the people needs while devising these methods and policies, standards?
Yes, yes, it's another good question. Here, can you see the screen?
Yes, yes.
Yes, yes. In the formal vision of this standard, we just focus on the saving, the energy and the water, the saving. But nowadays, the life is better, so people not only focus on the electric saving. I mean for the occupants, not for the country, for the occupants. They may be not concerned the electric or the water. They may concern the health, the comfort, and a good environment. So we change the index into the 5 performance, and we put the focus on the safety, the health, the convenience, and the environmental ability. So we through this method to approve to make the better life. And in this slide, it shows the detailed information. They include we can improve the indoor air quality to let the occupants have a good environment. And nowadays in China, the development stage, people need a better life, and a better life is also the policy. Actually, it's a word of the policy stated. So it's the reason, and also we do some we also do some survey to the people, especially the green building. They want a better environment, and not only to save some electric or save some water. Yes.
Okay, thank you so much, Dr. Lee. It was wonderful to hear to you and see all the work that you have done and that is being going on in China. It was wonderful to have you with us. Thank you so much for your time again and for all your help.
Thank you.
Okay, so now we have our last presenter, who is a very good friend, Dr. Mohammed Bilal Sajid. Dr. Bilal will be presenting about promoting energy efficient green buildings in SAARC region using EDGE green building rating system. Dr. Sajid holds a PhD degree in mechanical engineering. His primary research areas of interest are green buildings and industrial energy management. He has acquired distinguished professional credentials such as CEM, CEA, Lead Green Associate, True Advisor, and Edge Advisor and Expert. Dr. Sajid has worked on collaborative project with Arizona State University for promoting energy efficiency in the building sectors of Pakistan. He is currently working as assistant professor at USPK's NUST. Over to you, Dr. Bilal Sajid.
Hello, everyone, and thank you, Dr. Tanvir, for your kind introduction. Uh, as Dr. Tanvir told, I'm working at USP Casey Nest, and this center was founded by generous funding from USAID and the United States government. And our center and the faculty, they are working in several different areas pertaining to promoting energy efficiency and energy management and development of new technologies pertaining to uh, Pakistan specific and global needs in general. So, as Dr. Tanvir has already told, that I will be talking about use of edge green building rating system for promoting green buildings in SAARC region, and that can be the same methodology can be applied to most of the other developing countries as well. So, I believe I'm audible and my screen is visible to all of you.
Yes, you are audible and we can see your screen, Dr. Sajid.
That's great. So this is the brief scheme of my presentation. I will be taking around 35 minutes for my presentation, and the remaining 5 minutes would be for question and answer session. Initially, I'll talk about green building rating systems, and I'll not take more than 5 minutes for that. And then the main portion of my presentation is about edge, the energy efficiency features present in edge, and the methodology behind this software and the green building rating system. And then I'll be spending few minutes, around 5 minutes, to talk about some Edge certified projects as case studies and how one can benefit from Edge green building rating system and build his own professional credentials. And uh, the last 5 minutes of my presentation, they would be spent on giving you a brief or quick preview of how does Edge app or Edge simulation software look like and what are the features in it. Obviously, due to limited time, we won't be doing a problem solving or modeling example in Edge, but I'll show you how does this software work. And finally, we'll spend a few minutes on question answer session. As Dr. Tanvir has already been doing that, he takes questions at the end. But if I'm always comfortable, even if someone interrupts during the presentation and asks me a question. So both ways would work for me. Either you wait till the end or you just ask during the presentation. So just talking briefly about sustainability. Sustainability is any practice which benefits people, planet, and profit. And green buildings and sustainable buildings are at the very center of sustainable practices. And the earlier presenters have already talked in length about the features of sustainable buildings and what are the needs of sustainable or more specifically energy efficient buildings, and how do we take different design and operational considerations into the building. So I'm not going to talk about that. And now just directly jumping on the green building rating systems. I believe most of us must have heard about LEED Green Building Rating System, which is administered by United States Green Building Council or USGBC, and probably it's the most widely known international green building rating system. And second most important is BREEAM, which is a green building rating system developed by the UK. In fact, it was developed before LEED. So these are the two most popular green building rating systems worldwide, but there are several other green building rating systems like Green Globe, CASB, DGNB, that's the German version of green building rating system. Then there is Green Star. Those are the holistic green building rating system, which take into account all the different aspects of green buildings like energy efficiency, material efficiency, water efficiency, embodied heat, indoor air quality. And so all these green building rating systems shown at the bottom half of the slide, they are sort of comparable. But then there are few green building rating systems, and Edge is one of their family members. It's a holistic one. And then there are some specialized green building rating systems like Well or Fit Well, which just talk about the well-being of the building occupants, and they just focus on only one aspect of the green building, the living building challenge, that's about the net zero energy buildings. And then comes our uh, topic of the interest for today. It's Edge. It is one of those green building rating system, and as we can already see that a lot of green building rating systems were already present. So we need to see that what was the need for Edge, and why did they add a new green building rating system. So we'll see that there are some unique features in EDGE which were not presently available in the previously developed green building rating system. And the most important feature for this green building rating system is that it is specifically for developing countries. It's not for US, it's not for Canada, although they have started their certifications for some European countries. And second most important feature is that each and everything related to EDGE, the resources related to EDGE are totally free of cost, and they can be accessed from anywhere in the world. So as we saw in the previous slide, that there are several different green building rating systems pertaining to different countries in the world. And again, the most popular one is LEED by USGBC. But we need to keep in mind that LEED is not the only green building rating system which is administered by USGBC. There are several others like WELL, CARE, SITES, EDGE, ParkSmart, TRUE, and they all are administered by USGBC and its certification wing GBCI. So here what I want to emphasize is that these green building rating systems are not in competition with each other. It doesn't, one shouldn't think is LEED better or EDGE better, is LEED better or WELL better. In fact, they are all complementary. Each of the certification system caters to specific market needs and customer needs and requirements. So uh, we shouldn't say that EDGE is something which is superior or even inferior to LEDGE. It is for a different market needs, and we will now see in a moment that what does that market needs mean and how do we design buildings for developing, specifically for developing countries. And one last thing for this slide, a building can get multiple certifications as well. That it's possible that a building earns LEED certification and also earns EDGE certification. And there are few projects which have already obtained dual certification, and even it's possible to get more than two certifications. It's possible to get LEED, WELL, and EDGE certification as well. And then they all would be focusing on different features of the building and its impact on the climate and the building occupants as well. So now coming towards the main topic of our presentation, which is EDGE. What is the EDGE green building rating system? What are the features present there in this rating system, and how does this rating system work? So that's the most. This is the basically crux of our my presentation today. So EDGE, this is a green building rating system which has been developed by IFC, which is International Finance Corporation, an organization from the World Bank Group. And why do they develop this green building rating system? The purpose is to target emerging economies, the developing world. And why developing world is important? Because most of the progress and economic growth is happening in the developing countries. So if we talk about the developed world like US or Europe, they are already developed and most of the construction has already been taken place there. But in developing countries like South Asia or Africa, a lot of development is yet to happen there. A lot of buildings are being developed or being constructed or will be constructed in next few decades. So if we talk about the global climatic impact of buildings and how can we mitigate it, then developing countries are the most important market that should be targeted now, because they are going to build. So why not they should build green right from the beginning? And then IFC also realized that cost implications and uh, sophisticated rating system and their requirements would be, or in fact, they are a big hindrance in promoting green buildings in developing countries. So they have addressed both. They have removed the cost barriers by making each and everything free of cost and widely available. And the second thing is the complications. So they have made EDGE green building rating system a really a simple and easy to understand and easy to implement rating system. It's not like LEED, for example, or BREEAM. That doesn't mean it's inferior. It means it's simpler, it's more useful, or it directly addresses the needs and requirements of developing economies. So where does EDGE operate? It operates in more than 160 countries. So there are few notable exceptions. the EDGE certification cannot be obtained in US, it cannot be obtained in China, in Canada. Same on the down under, it cannot be obtained in Australia, it cannot be obtained in New Zealand. So these are the four important big countries that you can say where EDGE doesn't work. Other than that, in almost all of the countries it's work. And again, there are a few exceptions like Korea and Japan. But apart from that, there are a couple of countries like Iran and South Sudan, which have obviously political reasons, or you can say logistical reasons, because of which EDGE is not working there. But they hopefully they would be covered in near future. And then here you see France. I think they haven't really updated their map on the website. Otherwise, when we will be using EDGE software, we will see that they have now got it covered. And one interesting thing that I would like to share it with you, that I got my EDGE credentials around 1.5 years or maybe 2 years back. And at that time, EDGE was really only for developing countries. Only the countries in Eastern Europe were included, and no country from Scandinavian or Western Europe was included. But now most of them are already under the EDGE certification. So I would say at the moment only North America and Australia, New Zealand are the exceptions. Other than that, EDGE projects can be certified virtually anywhere in the world. And and you will see in a moment that it's really a simple and one-stop shop for the whole certification. So what does EDGE cover? It's an assessment tool, means it's sort of a simulation software or an app through which you can design your building and see that how much it would save compared to your baseline. And that's really easy to use. And then it's a global standards tool. In order, if you want your building to get EDGE certification, the only requirement is that it would need to meet 20% reduction from the baseline. And where does the 20% reduction need to be made? It's in the water use, it's in the operational energy, and it's in the embodied energy or embodied heat. In each case, you have to save a minimum of 20%, or you need to show minimum of a 20% improvement from your local baseline. We'll talk about it in a while. And then your project becomes eligible for EDGE certification. And then from the same software which you use for the assessment or designing of the building, the same software helps you through all steps of certification, including the pre-certification and then the final certification. How does EDGE auditor uh, play his role in certification? What does IFC do? How do the building owner see changes? How do building manager would be designing and everything? So all that certification system is run from the same app or software that is used for designing the green building or the project. So you can say that EDGE is a one-stop shop for whole design to certification process. And obviously, it's free of cost except the actual certification cost and the audit cost. So this is a preview of the EDGE certification software. It covers a lot of things. They are not all about just energy and water saved. It talks about the payback period, the initial first cost, and the operational cost and GHG emissions. So instead of talking about these now, we will see that where do they appear later, and we'll be talking about the EDGE software interface. So as I just mentioned earlier, that EDGE standard needs at least 20% saving in energy use, water use, and embodied heat. But when we talk about 20% saving, then we need to define 20% saving compared to what? When we talk about the baseline, it's the local benchmark, means although all EDGE projects need to have 20% saving, but that 20% saving will be different for different countries. For example, a building is designed in Pakistan won't necessarily get the certification as or the same savings if it is designed in a different country, let's say Philippines. Why? Because the local conditions would be different, and then the local practices or the local benchmark would be different. So the 20% is specific to every country, and this they have probably
incorporated this feature because people, and as one of earlier speaker also mentioned, that the other green building rating systems, they are designed for developing countries. So that takes into account their local baseline or their type of buildings. The buildings designed and constructed in those countries, let's say in Europe or in America. But EDGE doesn't have this restriction. It will take your local practices, local materials, and all those things combined as local benchmark. And then you have to prove, go beyond 20% of those baseline or benchmark. And then this was a simple certification which was offered when EDGE started. But now they have incorporated a couple of more higher tiered certification. One is EDGE Advanced, means if your building saves at least 40% through energy efficiency, not taking into account renewable or carbon credits, then your building can earn EDGE Advanced certification. And if you want to make your building carbon neutral, then there is the EDGE Zero or Zero Carbon certification that's also available. And this is the latest type of certification that has been offered by EDGE. And for that, in order to add an EDGE Zero certification, first you have to earn EDGE Advanced certification, means 40% saving in energy, and then the remaining energy consumption and the carbon emissions that can be balanced by on-site or off-site renewable energies or carbon offset. And then or one more important point that you need to consider for EDGE Zero is that it's not just based on design. The first two, the simple EDGE certification and EDGE Advanced certification, they are just based on design. But for EDGE Zero, you need to show your energy consumption for at least 1 year. So that means it's more targeted towards the operational performance of energy or operational energy consumption of the building. So that would not only take into account the design features, but it will also take into account the occupants' behavior, the way building is being used, and the energy is being conserved. So I would say this is more stringent and more realistic kind of certification as compared to the first two EDGE certifications. So how does EDGE certification cycle work? Basically, for when we talk about new building, it works in 2 steps. The first is preliminary certifications, mean you don't need to construct anything. You just design your building on the EDGE software, get the design approved from the EDGE auditor and the IFC, and then you can promote your building and do the marketing by telling that your project has received EDGE preliminary certification. And remember, you need to use the word preliminary certification because it's just based on design. So what is the benefit of preliminary certifications? One is obvious that it helps the building developers in marketing. And the second is that in some countries, they offer special incentives for green building loans. So the EDGE preliminary certification can help fulfill that requirement. And then the buildings or the project teams are allowed to have certain time, 1 year or even probably a bit more than that, during which you need to complete your building. And then once the building has been constructed, an EDGE auditor will do a physical visit of the building, do a checkup of the features that has been incorporated or installed there, and based on that site visit, the final certification will be issued. So obviously it starts from the design and then it's completed at the construction stage. The standard EDGE certification doesn't take into account the operational characteristics of the building. But if we go for the EDGE Zero, then obviously operational features and energy consumption and the utility bills would be taken into account. So now the EDGE software or the EDGE certification system that characterizes the project into 6 different types. Those are home, retail, hotel, offices, hospitals, and education. So they have at the moment recently changed the nomenclature from hotels to hospitality. Everything else remains the same. And EDGE certification is available for new buildings, core and share, retrofits, existing buildings. And there are a few other requirements that have been mentioned above. So before going into the detail of energy efficiency features of EDGE, I'll talk about briefly that what are the unique benefits of learning edge. This slide is basically for the students, but I believe the professionals, practicing professionals can also benefit from it. That it's probably the easiest and the simplest green building rating system. So you can start learning using edge, and then each and everything is available free of cost. And then specifically for developing countries, so people can't say it's something which is for US and you are just importing it here in our country. And then if you talk about the professional credential, they offer two different type of professional credentials: edge expert and edge auditor. And we will talk about their requirements later in our presentation. And then based on your learning and understanding of edge, you can expand your expertise to other green building rating systems like LEED, BREEAM, WELL, GNP. And since edge will provide you a strong foundation, so it will be easier for you to make a transition there. So when we talk about the freely available resources of edge, there is plethora of literature and learning resources which have been developed by IFC, and they have been placed on the Edge website. The most important is Edge User Guide. So basically, it accompanies the Edge software or the simulation app, and it explains each and everything. What is the theory behind that particular efficiency layer, and what would be the documentation requirements for the preliminary or design certification? What would be the documentation requirements for the final certification? So it's sort of a reference manual. And then there is another guide, which is Edge Materials Reference Guide. It talks about extensively about the different edge materials which have been incorporated in this rating system. And then this brief document, it talks about edge methodologies and how does edge work. And then there are a few more documents. This is one of my favorite. It's talk about India's construction material database of embodied heat and global warming potential. So basically, I would say this is a document which is probably a very, very relevant to SAARC countries, because it talks about the different construction materials that are specific to our region, and they have um, done a tremendous job in quantifying their embodied heat and global warming impact. So I would definitely recommend for everyone to have a look at these resources and this report as well. And then there is another document which talks about edge embodied heat materials. Basically, it covers all type of materials. The previous one is specific for SAARC or Indian region relevant materials. And then the edge cost model, it's the short document which explains how does edge calculate initial investment cost and annual savings and the payback period. Now coming towards the features of edge. So as we have already talked that there are three different kind of efficiency layers or the requirements of edge. The first and the most important is energy, then it's water, and then embodied heat. When we talk about energy, we can, for sake of our convenience, we can divide the energy efficiency layers in 5 different types: building envelope, HVAC, water, heating, lighting, and some miscellaneous layers, and renewable energy and the carbon offset. This is not a characterization done by Edge or IFC. It's I have just divided those layers in these categories just for sake of understanding. So you may have a difference of opinion on this characterization. So when we talk about building envelope, the first and foremost is window to wall ratio. Second is external shading devices. And we will later see how they are simulated or incorporated in design while choosing that software. Then the reflecting paints for roof, for external walls, insulation for roof, external wall. Then E-coated glass, thermal performance glass. These are for the Windows 7 and 8. And when we talk about HVAC, energy efficiency measures, the natural ventilation is available. You can simulate it there in the edge. Ceiling fans, especially for the star variable ceiling fan. Then the simple air conditioning system, you just need to specify COP. Then air cooled chillers, water cooled chiller, VRF system, vapor absorption system powered by waste heat. You need to take into keep in mind that it's not this layer doesn't apply to absorption systems which are using natural gas, for example. But there's a way to model those systems as well. And then air economizer, And we continue for HVAC, and now these are more towards the controls for HVAC, CO2 sensor for demand control ventilation, air tunnels for preconditioning of supply air, variable speed drives on fan for cooling towers for heat rejection to environment, VFDs or VSDs in air handling unit, variable speed drive pumps for the chillers specifically. Then there are features available for simulating ground source heat pumps, radiant heating and cooling systems, sensible heat recovery from exhaust air. And then after building envelope and the HVAC energy efficiency measures, there are few efficiency measures pertaining to water heating. That includes high efficiency condensing boilers, recovery of heat from generator, for example, like diesel generator for power generation for water heating, high efficiency boilers, heat pump for water heating, and then there are few features for heat recovery, like preheat water using waste heat from generator, heat recovery from grey water, heat recovery from laundry wastewater. And not every efficiency measure pertains to each and every type of projects. Later we will say that some features are available for few a type of projects like hotels and hospitality, and there are some features that are unique for small buildings or residential buildings, but this is an exhaustive list. And then talking about efficiency measures pertaining to lighting, that includes energy saving bulb, lighting controls, use of skylights, variable speed with fan controls. These are some miscellaneous measures. High efficiency refrigerant and cloth washing machines, refrigerated cases, high efficiency and smart meters. And finally, there is provision for use for harvesting renewable energy like solar water collectors, rooftop solar PV, purchasing electricity from renewable energy resources, and doing carbon offsets. But Edge always prefers energy efficiency over renewable energy. That first we should uh, achieve savings through adopting energy efficient solutions, and then later we should put renewable energy resources to balance our remaining needs. And the same goes for water efficiency. There are around 15 measures. I will just quickly go through them, like uh, low flow shower heads, low flow faucets for washing basin, low flow or water efficient water closets, water efficient greeners, kitchen faucets, spray rising spray ones for dishwasher, water efficient dishwashers, front loading washing machines, laundry trends, water reclamation system, obviously for large buildings, condensate water recovery system, water efficient landscaping, swimming pool cover, rainwater harvesting, grey water treatment and recycle system, black water treatment and recycle system. Obviously, since our webinar is energy focused, so we won't be talking much about them. But keep in mind that both water efficiency and energy efficiency are linked to some measures like water cooled chillers. And then the last criteria or the feature of EDGE certification is reduction in embodied heat. So it doesn't take into consideration the materials which are needed for the structure integrity of your building. For example, uh, it won't talk about the foundations, it won't talk about the pillars and beams and columns required for structural integrity. You don't need to reduce their embodied heat. It talks about other construction materials like floor slabs, roof construction, external and internal walls, flooring, window frames, and insulation for both roof and for walls. So we can simulate this as well in our Edge software or app. So how does Edge app work? I won't go into detail, but I will just give you a quick overview that it's location based, and then it takes the monthly averages of various parameters like temperature, humidity, wind velocity, solar radiation, and then there are two different algorithms for the type of building and how many occupants and are there. And then as we will see in a while, that it will show you a base case which is based on the existing practices in that country, and then the improved case which will show savings based on your selected energy efficiency features. And remember, the baseline is local. It would depend on the country where the building is being designed, and that will vary from country to country. So now just talking about a couple of edge projects. So this is one project in Istanbul, Turkey. Probably I should have put one from a SAARC countries, but and there are quite a few edge certified projects in India, especially Pune city. But here I'm just showing one from Istanbul. That project showed 35% savings in energy or operational energy, 42% in water savings, and 41% in embodied heat. And they didn't really do a lot of different features in our building. For example, while talking about energy savings in operational energy, we did reduce window to wall ratio, reflective paints on external walls. They insulated their walls and roof. They used low E window glasses. For the HVAC, they adopted VRF systems, and for water heating, they have high efficiency boilers. And then they also incorporated LEDs in their lighting controls in their building. And with the help of these few important energy efficiency layers, they were able to achieve 55% saving from their baseline. The same goes for water efficiency and embodied heat. And this is another project from Mexico. Sorry, I have written New Mexico. It's not New Mexico. It's not from the US. It's Mexico. 45% savings in energy, 35% savings in water, 52% savings in embodied heat. And these are few features they have adopted or incorporated in their building. And I would like to tell you that there are quite few edge case studies available on the Edge IFC website, and they obviously have incorporated more details on these projects. So I would recommend all of you to have a look at those, some of the case studies, especially pertaining to your country or your region. And then if someone wants to learn Edge and become recognized in using Edge and making it part of its professional practice. So first, before appearing for Edge expert exam, you need to attend their Edge training that's offered by both GCI and STEP STS, and you need to pay $150 and have a certification or training that can be done in person, online, either recorded or on demand videos, or through live face-to-face person trainings. And then you can appear for Edge exam in Prometric. It costs $100, and I believe Prometric has offered several of its exams. Even now, they are allowing the users to appear from home. I'm not sure, but I think this applies to Edge Expert as well. So when I appeared for Edge Expert exam, there were no practice exams available, but now they have designed one practice exam which you can pay for $30. And it's really up to you if you want to do some practice before going for actual exam. And then the Edge Expert or Edge Auditor training, that's the higher level of training or professional credential, and it's not usually offered, or it's not commonly offered. So maybe once in a year, and at GBCI or USGBC and things STEP STS, they have different requirements for Edge Expert. For example, things STEP STS, they have their internal training program, but anyone can attend Edge a auditor exam or training for GBCI. That costs around $400, and then you need to pay credential maintenance fee. But in order to become Edge auditor, you first need to become Edge Expert, and then need to have some practical experience of green building projects. And those professional credentials are listed on the website. For example, you would see my name in Pakistan, but that doesn't mean I or anyone can just work in his country. Edge Expert and Edge auditors can work anywhere in the world. They can design the projects, they can audit the projects in any country where Edge IFC certification is valid. So steps for Edge certification, we have already briefly covered those steps, so I'll skip this slide for now. And now just coming towards a brief overview of how does Edge app look like. So this is a screenshot from Edge software. You can just create your own account by going on the Edge Buildings app website. You can just Google it or go from first go to the Edge IFC website and from there get a link and go to the Edge app website. But you don't really need to create your own account or do a sign in here. You can just go and use it. But if you don't create your own account, if you don't uh, log in from your account, you won't be able to save your project. So that's an additional benefit. Since this is free of cost and it's very simple, it would take a minute just to create your account. So I would recommend that you should first create your account and then keep saving your project so that you can just resume from those projects in future. And then you would design this project, your projects in Edge app, but then you would be able to download very professional looking reports from this file menu, and you would be able to share your projects with other professionals or auditor or building owner through this menu. And here in the dashboard, obviously, if you have multiple projects, you would be able to see. But this is just an overview of about using Edge. Now we come to the crux of our Edge software. First, you need to select the correct or most relevant type of the building project that you are going to design. It's for residential, hospital, retail, hospitality, educational building. So first you would select your relevant type, let's say residential. And then you would have these 4 tabs there. So you first need to select the correct tab and then a correct branding type, project type, and then go into the details. First, you would do some design. You would provide some design relevant features or information which would be covering your whole project, and then you will go into further detail about designing or incorporating energy efficiency in your project, water efficiency, and water heat. So on the design tab, first of all, you would select your correct location between the country and your city. And then income category in some type of project, it makes certain differences. And then within the design tab, you would need to provide the details of the area of your building, how many, let's say if we are talking about residential building, a number of apartments, unit area of apartment, how many persons are there in a single building, how many units are there in the whole apartment building, things like that. So they will change on depending on the type of the project. But a very important and interesting and unique feature of Edge is that you really don't need to have each and every information available with you before you start designing your project. Edge does provide, I would say, starting values or default values for every type of information that it needs. If you have this information available from your project, just enter it. Otherwise, just use the default values to get an idea that how does the project would look like. And later, when more and more information is available, you would keep refining your simulation of the design. And then you need to select the building systems. That does your building have cooling systems, the ACs, does your building have space heating. Depending on your project type, you can select yes or no. And then there are certain key assumptions for your base case, that what are the type of fuels used in your country or in your building, what is the cost of fuel features probably. Then you need to provide the weather details. So you right from the beginning, you don't need to treat with these key assumptions, just keep them as they are. But later, when you would be defining your project, especially if you are going for your certification, then you should pay close attention to each and every value listed in the key assumptions. So once we are done with the first design tab, then we can just click on the second tab, which is energy. And then it will show you all the energy efficiency measures which are available for that kind of that specific type of project. For example, here I'm showing a residential building, so it is showing me the energy efficiency features available for homes. So I can select any of the features that I want. And what will happen that on the right side, you have 2 bar graphs. One is for the base case, which will remain the same. And the second is improved case. Whenever you will select a feature, it will show in you real time that how much energy saving would be achieved if you incorporate that feature in your building design. And that will be real time. You don't need to run simulation. Whenever you will click on the left side, it will show you immediately the savings or the anticipated results on the right hand side. So you will just keep selecting a variety of different measures that you want to incorporate in your project, and then you need to get at least 20% saving to become eligible for EDGE certification, but you can go beyond maybe 40, 60% depending on how do you want your building to be designed and constructed. So this is a bit zoomed in view of the same graph which was here on the right hand side. But apart from the energy savings, which would be in terms of EUI, kilowatt hours per square meter per year, you would also be, the EDGE would also be showing you the amount of tons of CO2 or greenhouse gas emissions that would be offset or reduced because of incorporation of energy efficient features that you would be doing for your building. So that gives you a good idea that how much carbon emissions are being saved through your energy efficient design. So the second efficiency tab is related to water. We'll briefly talk about few water efficiency measures available in EDGE. So you would pick few of those, and then the anticipated energy savings would appear in the improved case. And again, as I told you earlier, at least 20% is required for EDGE certification, but obviously you can go beyond that. And as we talked in the design tab, and it remains valid for the whole EDGE software, that EDGE would be always be providing you default values, even if you don't have the data for your building or for your project. So you can just keep using the default values to get idea about how things would be behaving in your actual project. And once you have your design, more details available from your design, then you can incorporate those actual numbers in your simulation, and you would get better results. But it won't stop you from simulating your building or incorporating the effect of different type of efficiency measures that you would be selecting. Same goes for materials. There are 7, 8 different types of embodied heat efficiency measures. You just select any of those, and then the improvement through the embodied heat saving would be appearing on the second graph on the right hand side. So this just concludes a quick overview of EDGE green building rating system and a sneak peek into the EDGE simulation software. So I'll be more than happy to answer your questions about my presentation.
Thank you so much, Dr. Bilal Sajid. Uh, to start with, I have a question for you. Is there any research or trial version available of this app, Edge, or like for students or developing countries, such as the example of LEAP?
Yes.
And how is this different than the LEED certification?
Right. So the first part of the question pertains to the software availability. Full functional software is available on the website. You don't need trial version or specific student version. Full professional version is available on Edge website. Just go for it. If you create your account, that's better. Even it would work without your account. So the cost or anything is not a hindrance for using its software. The second part of your question pertains to difference between Edge and Lead. There are lot of differences, but I would just talk about the most important differences. The first thing is everything is available free on Edge. The second is that leads take into account several different aspects of green building. For example, it starts with location and transportation, then it talks about sustainable sites, then it talks about energy and atmosphere, then it talks about, or before that, it talks about water efficiency, then it talks about indoor environmental quality, then it talks about regional credits and pilot credits and regional priority. So there are around 6 different categories, but in Edge, there are just 3. It's energy efficiency,
Okay.
water efficiency, and embodied heat. So it's much, much simpler than that. Then there are prerequisites in Edge, which you must need to meet. But Edge is more flexible. You can pick any kind of efficiency measures. The only requirement is that you need to achieve 20% savings from your baseline. Then another important aspect is that Edge uses Lead V4 uses HREN 90.1 2010 version as its baseline. So it's the same throughout the world. But Edge uses the local practices as its baseline. So these are some of the differences.
Okay, and is it similar to the portfolio manager or Energy Star, or is it different than that?
No, it's different than that. If you talk about in terms of ease of use, it's almost the same. Probably it's a bit easier. But portfolio managers are more related to operational energy aspects of your building. This is more related to your design features. So if you just want to get an idea or see an analogy, I would say Edge is more uh, resembles a red screen expert in terms of its methodology and its features and its approach.
Okay, and the reference material that you mentioned during the presentation, is it available for free,
Right.
like on their website?
Yes, everything is totally free, and you even not need to create an account. Just go on their website and download it from there.
Okay,
Or
great.
even you can access some of the manuals from within the Edge app as well.
Okay, great. Then there is a question, sir, that you mentioned many good reasons for having the an EDGE certified project, but can it effectively contribute to a brand of corporate sustainability and increment in property evaluation as well? Hello, Dr. Bilal?
Yes, it serves both purposes. As you know, IFC, this basically that's the International Finance Corporation. That's sort of an organization which is targeted towards funding the projects. It's a business-related organization. So they have put a lot of efforts in uh, promoting corporate sustainability and green financing through Edge software. So that's really an important aspect of Edge certification. And you can go to the Edge IFC website or even contact IFC to learn more about uh, how the financing side of corporate sustainability can be promoted through Edge software.
Okay. Sir, there is a question that the level of support from the H team, is it the same like for all the project, or does it depend upon the worth of the project? Dr. Bilal?
Dr. Tanvir, there is some distortion in the sound. I couldn't hear you. Can you please repeat
Yes,
it or just type it?
the question is the support that we get from the H team, is it the
Uh,
same for all the
and
project, or does it depend upon the worth of the
I'm
project?
sorry, I again can't hear you.
Uh, the question is that the support that we get from the H team, is it the same
Right.
for all the projects, or does it depend upon the
The
worth of
support
the
that you get
projects?
from, I know it's the same. But if you are just using the software for free, obviously, then they would be providing you the minimum support and would be mainly addressing your questions if there is a problem or if there is a glitch in the software. But if your project is certified, if you register your project, then obviously they won't be differentiating between whether you are paying little money or more money. And if you will go into the details, you will see that IFC earns very little money from this certification process. The main costs are related to your Edge auditor fee and the certification fee, which goes to either USGBC or GBCI or the other party, which is ThinkStep SDS. Edge IFC makes very little money out of it.
Okay. The last question, uh, the building orientation, does it have any impact on EUI of the building? And what about the baseline model? How the software take local practices into baseline model?
Well, first question is about the orientation. Yes, it does take into account the orientation. You would see that right in the beginning of your design, you would need to specify the orientation of your building, and then later when you would be telling the software about your windows, that would be asking you specifically the window to wall ratio on the west side, south side, east side, north side. So that would be taken into account. The orientation. The second question, part of your question, I just forgot. What did you ask?
The baseline model, how software
Right.
take local practices into the baseline model.
Right. So the baseline is something which is built in the software. It's at the back end. You can't really go and change it. You can change certain things in the key assumptions, but before launching this software, as IFC did a very extensive survey of the target countries. For example, in Pakistan, you would see when you go to the baseline, you will see that the construction materials is bricks, the common brick, and the window to wall ratio is similar to our. So that's more of a survey based. And if you really believe that there is something which needs to be changed in the baseline for the country, you can write an email to the IFC, and then they will be get in touch with you, and based on the evidences that you would be providing, they can improve your baseline. But in short, it's based on their previous surveys and it's built in. You can't just go and play with it.
Okay, sir. The last question, I guess you mentioned that in the slides, but what is the cost of the EDGE certification?
So you are talking about the building certification. So that depends on the square feet gross floor area of your project, and that varies. That mainly depends on gross floor area, but then there are few slabs that if your project is smaller than 5,000 square meter, certain cost will apply. If it's greater than that, a different cost will apply. But this is not fixed. And the reason is that there are two different organizations through which you can get your building certified. One is GBCI or USGBC, and the other is ThinkStep SPS. So if you really want to get your project certified, you can get competitive quotes from both the organizations. And then obviously you can go for the one which is more cost effective. But usually they are quite comparable. And the same is another cost that you need to take into account is the EDGE auditor cost. And what happens is that GBCI, if you go for GBCI, there will be separate fee for auditor and separate fee for GBCI certification, but ThinkStep SPS just gives you a lump sum.
Okay, sir. The last question is from Dr. Adil, and who presented earlier.
I just read it.
Yeah, and it is that the credibility of EDGE certification, is it same as of LEED in Pakistan and the SAARC member states?
Yes, so I would say it's a bit of a subjective question. For example, as I told you that the EDGE and LEED, they both are administered by USGBCI or GBCI, their certification. So it's the same certification body which is giving you the both project, both certification. So in terms of credibility, I would say both are the same. In fact, EDGE includes a site visit of the auditor. LEED doesn't include. So that's one way of thinking. But at the same time, for example, EDGE is not going to take into account your indoor environmental quality. LEED does. So it's more complicated, the LEED one. So I wouldn't really say that which one is better, but I can tell you LEED is more complex, EDGE is simpler, but that doesn't mean the energy efficiency or the sustainability impact of EDGE is any lesser than LEED. Basically,
thank you so much. Thank you so much. Thank you so much, Dr. Mohammed Bilal Sajid. I mean, it was a wonderful presentation, and thanks for your patience. You answered all the questions. It was very nice to have you. So I would like to thank you again on behalf of SAARC Energy Center.
Thank you very much. And thank you very much to all the participants for listening.
Thank you again. Okay, so with this, I may like to conclude our webinar. Thank you everyone for attending today's webinar. We had listened to some excellent presentation delivered by our distinguished presenters. All the presentations will be available on SAARC Energy Center's website, which is www.saarcenergy.org very shortly. We would love to hear any suggestions and comments for further improvement, plus any suggested topics of your interest on which you want us to arrange future webinars. We would gladly do that. With me signing out, thanking all the presentation and participants again for joining us today, and looking forward to see you next time. Bye bye for now. Thank you.